Hello, everyone, and welcome
Hello.
to this deep dive session on standards, AI agents, their protocols, and we're going to go through a walkthrough of some of the key protocols, in particular MCP and A2A, but we'll talk a little bit during the introduction about the other protocols. There's quite a bunch of them lately, so it's a very active area. My name is Guillaume L. I'm a developer advocate at Google, focusing on generative AI. And today with me, whichever who starts.
Okay, I go first. I'm going to be a sandwich of Googlers. So my name is Emmanuel Bernard. I work at Red Hat, and I've done a lot of open source, co-founder of Quarkus, worked a lot and led the Hibernate portfolios and many other things. And I'm a Java champion just like you. And then at the moment, I'm the chief architect for middleware, helping them move towards the right direction. Middleware being everything you use to write applications, so stacks, libraries, Kafka, etc., etc.
But if you said the direction, so maybe it's leftware, middleware, rightware, or no?
That's a good question.
Okay.
And
thanks for the couple of people who tried to laugh at my joke. Thank you. Thank you. I appreciate it.
He's very famous in France for
my jokes, but they don't translate well in English.
Oh, we do a podcast together called Les Cascadeurs.
In French.
With lots of jokes, but in French. So up to you. So sorry, Maite, go for you.
It's okay. My name is Mehta Tamel. I'm a developer advocate as well. Same team as Guillaume, but I'm based in London. And yeah, I used to do Java, and then I switched to C# when I started working for Microsoft. Nowadays, I do mostly Python because of LLMs. And yeah, today I'll cover the MCP part of the talk. So yeah.
All right, and well, a few links if you want to follow us on the various, social networks and such. So, the theme of the year of this year's DevOps conference is inspired from the Tron movie, and one of the famous quotes is, "Greetings, program!" So I'm greeting you all, and thanks for being here. I'll start with a few definitions. I'll do some parallels with the Tron movies, and I'll cover in the introduction the various protocols that are looming around these days. So what is an AI agent? So the more formal definition of what an AI agent is it's a kind of system that has access to its environment. It can sense its environment through sensors and can act upon the environment thanks to actuators. And if you put that in the context of LLMs and AI agents in particular, so an AI agent is actually some kind of service program tool, etc., that uses some AI model to perform some kind of goal-based operations. So it's like when you give a prompt to an LLM, your role is to do something. That's exactly the kind of goal we're speaking about here. And those LLMs have access, those agents have access to tools to be able to sense and act on that environment that the agent evolves in. And I like to frame this also as an equation in a way. So really, an AI agent is an LLM that you're going to send requests to. There's the notion of memory, because it's a conversational kind of interaction. So you can send message, get responses, but you want to keep the context of the conversation, because LLMs are stateless, so we actually have to always send the whole conversation. And potentially long-term memory as well. It's not always necessary, but it can be useful. There's the planning phase, because the LLM has to figure out what has to be done. Should I decompose the big goal into subtasks? And in order to reach that goal, maybe there are some tools that need to be invoked and that the LLM has to interact with. And if you look at the characteristics, or let's say the flow inside those AI agents, so there's this thinking phase where the LLM is going to analyze the user prompt, the system prompt, the data that it's given, the context. We speak about context engineering. It's the next thing after prompt engineering. That's a higher level kind of prompting, let's say. And that's at that point that the LLM is able to understand what's the goal, what it has to do. Knowing what it has to do, it has to plan and say, okay, I've got these tools. Here's what I could do to reach that goal. Maybe I can invoke that tool, pass that kind of parameter to the tool, etc. So it's going to plan and build like a graph of subtasks, or somehow it's going to plan what it has to do. Then it can act. So it's going to request API calls to be made. Maybe we're going to do some retrieval augmented generation searches, or potentially invoke other agents. It's not just a single agent world. We're speaking about multiple agents potentially. Or the agent could also request the help of a human, because at some point maybe we need human approval, we need extra information. So at that point we can also have a human in the loop, so like another little loop here in that corner. And another optional characteristic or phase is the reflection. Potentially, an AI agent can reflect upon what has been generated so far. So, for example, if you have an AI coding agent, maybe it's going to generate some code, and then you're going to review the code with another LLM or the same, or it doesn't really matter, and say, yeah, well, the code could be improved. It's not up to the standards, or maybe there's going to be a bug there. So here's another round, and potentially you can loop several times till it reaches a certain level of quality, or yeah, a score or something like that.
A quick question for you.
Yep.
You said there is a human in the loop. And you mentioned context engineering. Do you think there'll be vibe coding engineering, or is that an oxymoron?
Vibe coding engineering. Wow. Yeah. I don't know. To be honest, no. That's a good point. But the key message I just want to share here when I speak about human in the loop is that it's. Tron, it's a science fiction movie, but AI agent is still science fiction as well. And the place or the role of the human being is still super important today to get AI agents to go in the right direction. And you can't leave them alone on their own for forever. So you can't vibe everything away. And humans still play a super important role. Not sure it really answers your question, but that's my answer.
Nice walk around.
So yeah, you've got a single agent, but nowadays, because you've got several frameworks, several languages, several things, and several agents that are popping up in your, let's say, ecosystem of tools and software, etc. So agents can also call and interact with other agents. So we are going to go into a multi-agent kind of systems. And there are protocols for that we're going to cover today. All right, so back to the grid, back to the parallel I wanted to make with the Tron movies, and then I'm going to list the protocols. So there are 3 Tron movies. The first one from the 80s, 81, 2, or something like this. So that's the one on the left. What was interesting, and it's a kind of a historic perspective, back in that movie, the programs were kind of rule-based AI. So if you think about also the parallel with the AI history of the AI winter and that kind of stuff, the AI systems back in the day were more symbolic systems, expert systems with real algorithms and graphs, going through graphs and nodes and so on. So it's more a programmatic approach compared to those neural networks-based AI models that we're using nowadays. But the other little funny thing I found in the original Tron movie was the evil character was actually the Master Control Program, MCP. But it has nothing to do with Model Context Protocol, but I was like, oh, whoa, that's an interesting... So, well, it's not really related, but that was the bad guy, the MCP, right? So we'll see if it's a fight between MCP and A2A. I don't know. No, they are complementary, right?
Quick break. I know some people are up. Yeah, there is some seats at the first,
yeah, there are plenty,
first seat or second row. So
don't hesitate.
Feel free to go there.
In the second movie, released like 10 years ago or more, what was interesting was that the AIs became more self-aware and emerged from the grid. And what was interesting, again, in terms of parallel, is that as we started working, so Google invented the transformers neural network architecture back in 2017, I think. And the fact that we have bigger GPUs, bigger data models, sample corpus of data, etc., bigger GPUs, bigger everything. We managed to train those neural networks on bigger data, etc. And we noticed that some capabilities emerged. So an LLM that was just parroting what a human being can say or write, then suddenly became able to translate from one language to another, started to do all sorts of tasks, write, well, summaries wasn't the most complicated task, but new capabilities emerged. So it's a bit like that parallel with the AIs emerging from the grid in Tron. And the other problem in the movie as well, there was an AI alignment problem, but there's that problem as well nowadays with LLMs, in the sense that there's bias that's introduced in the corpus of data, the way the model is trained. So again, I see similarities again. And this week, at the end of the week, there's going to be Tron Ares, the 3rd edition. And the other parallel that I found, which was kind of interesting, is that in the first 2 movies, the characters were entering the digital world. But now it's the opposite. It's actually the AI, well, I'm going to say AI agents for the talk, but which are interacting directly within the real world. They enter the real physical world. And the AI agents that we have, thanks to tool calling, etc., tool use, they are actually interacting with the real world. So we're going to invoke APIs, take actions, maybe send an email. It's an action. It's still digital, but it's an action. And maybe an API could move a robot or something, because there are LLMs for robotics and things like that. And the risk as well is that if the AI is actually entering that physical world, if you give too much autonomy to those AI agents, then that's more the era of Terminator kind of movies and such. So let's see what the future holds. And again, it's important to know that you are the developers who put those LLMs and agents into production, and the fate of humanity is in your hands, okay? Don't forget about that. Right, so when we speak about standards and protocols, I would like to say for whom those standards and protocols are, because there are clearly different, I was going to say actors, not actors, but different kind of AI agents. I'd like to separate them in 3 categories. So what I call AI assistants on the left, I forget if I have, no, I don't have an animation. AI assistants are things for me like Cloud Desktop, like Gemini.google.com, etc. Those are, or ChatGPT, these are assistants that you can interact with, have a conversation with, etc. There are coder agents, so it's more things like so Cloud Code, Gemini CLI, all the GitHub Copilot stuff integrated in your IDE, etc. So that's the AI agents that help you be more productive, code, etc. And then there's a 3rd category, which is actually the AI agent that you develop, that you program yourself using different frameworks and LLMs and so on. So I'd like to separate those 3 categories because there are protocols and standards for those different categories. So let's do this in, well, so of course we're going to spend the biggest amount of time on MCP and A2A, but I'd like to mention those other protocols. The first one I'll mention is ACP, Agent Communication Protocol. It's a protocol that was launched by IBM not long ago, but just, I forget if it's like a month ago or less. So this deck is pretty fresh in terms of information because things move so fast in AI these days. So there's ACP, Agent Communication Protocol, and they announced, although the protocol was pretty new, just like A2A, Agent-to-Agent Protocol, was already pretty new, but they announced that, oh, well, ACP is now part of A2A. So we already see some existing nascent protocols merging already, right? So there's a plethora of protocols, but some are actually merging. So this one was pretty similar to A2A, but we'll see the details, so I don't give more details about this one.
I think it's not quite part of. I think when you read in the details, what they say is A2A is a nice base. We have some interesting idea in ACP, and we'll merge them as appropriately into.
Yeah, so they are expanding A2A with all the key concepts of ACP.
Yeah.
And there are protocols that are nicely and neatly designed, like A2A, because they are extensible, which means that, well, when you design a protocol, you never know how people, how developers, etc., are going to use that protocol. So maybe we can think about ways to let developers, companies expand or extend the protocol with other things we haven't really thought about. And A2A is designed that way to be extendable. And there's a new protocol called AP2 for Agent Payment Protocols that was launched, I don't know, 3 weeks ago or something like this. And it's actually an extension on top of A2A. So again, we see protocol emerging, we see protocol extensions, and it's a very lively ecosystem. And another ACP, this time, Agentic Commerce Protocol. It's OpenAI this time that decided to launch something that is somewhat competing with AP2, but is actually quite different. So it's actually not so much of a protocol, so that, oh yeah, and I forgot to mention, let me add a few details here. What's interesting with AP2, before I move to the other payment protocol, is that the idea behind this protocol is that human beings give a mandate to an AI agent to spend some money on something. So let's say I have an agent and I want to buy something, a new guitar, because my daughter broke my guitar 2 days ago, for real. And I want to buy maybe a new guitar for less than $400. So I can give a mandate to the AI agent to allow it to buy something on Amazon, but less than a certain amount of money. So the human being is in control of this payment, let's say. The approach taken by agent, so another ACP, that's the second ACP protocol that we're seeing, Agent Commerce Protocol from OpenAI. The approach is quite different. It's more, so it's not because it's OpenAI and I work at Google that I'm going to say that, but it's more a walled garden kind of vision of the payment protocol, because it's more, the idea behind that is to actually create and something that they announced yesterday is a proof of that, is to allow people to buy stuff within ChatGPT. So you search for some products show up with partnerships with some other companies that sell stuff, online shopping and that kind of stuff. And they show up in ChatGPT. And then there's the partnership with Stripe, so that the checkout button on that product goes through payment through Stripe. So it's more an extension so that ChatGPT can let users buy stuff, rather than what for me, AP2 is more of a real protocol, because AI agents of any kind, and not just tied to one particular platform, are actually able to make payments via the mandates that the user
gets. I haven't read the details, but it feels more like AP2 is for developers to integrate in their app.
More, yes.
More than the agentic commerce. But again, I haven't got into any details, so I might be very
And just yesterday, OpenAI did their what is it called? Dev Days? I'm not sure about the name. Their conference where so Agent E-commerce Protocol was announced like, let's say 2 weeks ago or something like this. And yesterday they announced new things to be able to build widgets within ChatGPT, so that it makes it easier as well to, let's say I'm Amazon and I want to do shopping within ChatGPT. Then Amazon can provide widgets so that they are integrated into ChatGPT and they can click on the button.
Next, we need ad blockers for AI.
Yeah, but it exactly, ad blockers. ACP, and then a third ACP. So this time it's more on the coder or coding agent tools rather than the AI agents. And ACP this time stands for Agent Client Protocol. So it's a protocol so that IDEs like JetBrains, IntelliJ IDEA, VS Code, etc., can use the same standard, the same protocol to interact with coding agents. So let's say, I'm using Gemini CLI. I want to use Gemini CLI integrated into my IDE. Then I could implement the ACP protocol And if I've done that once, any IDE vendor can integrate my coding agent. So it's really a standard to standardize the way a coding agent is integrated into your developer tools. And just yesterday, again, the information in those slides are super fresh. JetBrains, so this protocol was launched by Zed. I don't know if you know this VS Studio kind of...
it's another villain in some movie, I think.
Yeah, maybe it's another villain. And JetBrains just announced yesterday evening that they, or yesterday, yeah, I don't know if that was the evening, but I read the news in the evening, that they are going to partner on that ACP protocol because, I mean, JetBrains, they know a thing or two about IDEs, right? So and AI agents as well, coding agents. So they are working with Zed to actually work on that protocol and in the best possible way to integrate into IDEs. So this is quite promising. And instead of reinventing the wheel and in the integration in each and every IDE, you can have a protocol instead. And back to the left, the first persona that I identified. When you use things like Claude Code, there's a Claude.md file that you could use to define, yeah, you're allowed. So I'm a Java developer. I want to use Java 25 with streams, with, I don't know, I'm using Gradle for building. I'm not using Maven. If you want to run the tests for me, you have to use that command, etc. So it's a Markdown file that tools like Gemini CLI, Claude Code, or others are able to read and use to code the way you want them to code, basically. And what's interesting here is that, so it's not really a protocol, or it's more of a standard, I would say. It's the way to describe, it's a Markdown file to describe how the agent, your coding agent should work. And there are already several such agents that follow that idea, that principle. So initially, each had a different name, so there was Claude.md, etc. But either you can, symlink them, or potentially, or more are supporting the named file agents.md rather than their proprietary kind of name. The last thing, I forget if it's the last one, but the thing that's interesting with LLM-based agents is that we're building conversational interfaces. So it's a chat, right? So whether you show the chat as a chat is an important question, actually, or completely hide how the LLM is working under the hood in your application when you create your own AI agent programs. But in the case of conversational interfaces, I don't know if you're like me, maybe I'm a bit too old school, I don't know. But it's quite frustrating to always have to type everything. So let's say I'm writing a trip planning AI agent. I'm actually more productive when I have widgets like I select the destination, the dates, the number of persons, rather than, oh, I have to write a novel about, yeah, I'd like to do a wonderful trip in the Bahamas and with my beautiful wife, my 3 kids, my whatever. So I'd rather use visual components, UI components. And that's the idea of two specifications. MCP UI, which suggests that we can actually create components. I think they do both React and web components, so that you have in the chat conversation richer UI elements that you can interact with. So for example, you may have something to approve or refuse something. You may have widgets for selecting a location for the trip planner in particular. And so they provide different kind of web components and React components, and also server integrations on the MCP side of things. So it's really tied to the MCP protocol. So I think no, I didn't put an extra illustration, but the idea is to somehow, between the LLM calling a tool and the interface that the user sees, there are these UI components. And the other one I wanted to mention is AG UI. So this time it's at the agent level, not at the tool level, but that's the same idea, to add again, UI widgets in the conversational interface so that you interact with the AI agents more visually. And so you've got your applications, and there are implementations for different frameworks, AI frameworks. For example, they haven't updated. Oh, they're coming soon. Google ADK that I'll mention, the agent development kit from Google. So it's there already. It's been announced.
So, for example, that's to enhance the classical chatbot experience with widgets.
Yeah, exactly. So it sits in the middle and it's visual. And for example, they have some cool demos online that shows how, for example, you have a more classical UI, like a normal web app that you would have built, and then you can really inject or infuse the AI directly in those components, or continue to type directly in the chat. And then, so I'm not going to show that demo, but if you type in the chat area at the bottom right here, it can populate that UI as well, depending on the context of the conversation. So it's interesting, and I think it's a promising kind of level of integration with those AI agents. In this presentation, we'll use different languages and tools and frameworks. We'll have some Java, of course. Mete will do quite a bit of Python. So
Java.
Don't leave the room if there's too much Python, because we'll have Java, I promise. But we start with Python. So
who uses Python?
A bit less, right?
Less.
So some Java, some Python. We'll be using Quarkus as a framework. Yes. What is Quarkus? So Quarkus, you know something about it?
Yeah, I know something about it. It's I like to call it a stack, because it's not a framework in the sense that it's an ecosystem with a couple of opinionated choices to make you more effective. So it's a stack to write any kind of application, a REST application, an EDA application, a CLI application, and many more, and agents, of course, nowadays. It is super performant, not only in like raw performance requests per second, but also requests per megabyte per second. So that's the two big things we're really pushing hard on. The developer experience is really awesome with a hot reload, just like PHP or Python, but in Java. Dev UI to help you accelerate. So you as a developer is really at the core of the experience. And I think that's
yeah,
good.
And there are a bunch of sessions at Devox that mention Quarkus in a way or another.
If you're interested, go to the Red Hat booth, see me or any of the other crew out there.
And we'll also be using LangChain4j in some places. I'm a committer on LangChain4j. I'm also a committer on ADK for Java. That's the agentic framework from Google. Mete will show some ADK for Python, because ADK is also available across different languages, and more languages are coming. And now it's time to dive into MCP.
And I forgot to say, Quarkus being a stack, it embraces LangChain4j and reuses all of that for the AI aspect of things. So we're not reinventing the wheel here. We're embracing almost call it a de facto standard in Java.
All right, let's see.
Close your eyes. You're not supposed to see dark. I'll tell you when you can open your eyes again.
Can you see? Yes.
Okay, you can open your eyes.
Good. Okay, thanks, Guillaume, for the intro. So let's dive into MCP. So what is Model Context Protocol? It's basically an open protocol that defines a standardized way to provide tools, basically functions, and context to your LLMs. When you look at the definition from Model Context Protocol.io, they talk about providing context to your LLMs, but I had to call out the tools because I think that's what most people use MCP for, to enable large language models to be able to call external systems via functions. And I also had to specify functions because I think these are, at the end of the day, just functions that you want to expose, but we like to invent new terms in software engineering, so we call them tools now because it sounds more sophisticated, maybe, I don't know. So that's what MCP is, and just to recap, though, I mean, we had tool or function calling before MCP in most large language models. And the way it worked, just to recap, was that let's say someone comes in and asks a question about the weather in London. So how's the weather in London? Then you have your AI app with its functions. So let's say it has two functions that get weather and get currency. Then what we do is that we pass the question, and then we also tell the model these are the functions available to you, get weather and get currency. Then the model picks the function that it wants to call with the parameter that it wants to call. So in this case, it tells us, can you please call the get weather function with London parameter? Then we have a weather server somewhere. We call that on behalf of the large language model. So we call get weather London. We get the result back, forecast rainy. Then we pass that back to the LLM. And then the LLM can finally reply back in natural language, it's raining in London, and we pass that to the user, right? So this is well known, and this is what we've been doing. And it's kind of like a dance between your application and the large language model and the service. And we tell the large language model what's available to it, and then we call it on its behalf, the services that it needs to be called, and we pass that result back to the LLM. And then LLM basically formats that in natural language, and we get a nice result back to the user. And if we have another question from the user, like for example, what is 1 British pound in US dollars, we do the same thing with a different service, right? Something like that. And in the end, we respond back with the answer. So that's traditional tool calling that you probably all know about. Now, the problems with traditional tool calling is that, number one, you need to maintain the integration code between your AI application and external services. So everything that happens here, you need to kind of do that integration. And secondly, there's no way to reuse these tools with other AI applications. I mean, of course, there are ways. Like, for example, if you define these functions in a library, then you can import that library in multiple places, and you can do reuse in that kind of way. But what I mean here is that there's no service that, whether service, integration service, for example, that you can reuse from multiple AI applications. So before MCP, we used to have our AI application, we used to have our tools, and we had this one-to-one integration that we had to maintain between our applications and the tools. Now, after MCP, we have our tools. Then we start by wrapping those tools into MCP servers, okay? So now these MCP servers, they can be local to your application, or they can be deployed remotely somewhere else. It's up to you how you want to do it. And it doesn't also have to be one-to-one. So an MCP server can have one tool, but it can also have multiple tools as well. And typically, it will have more than one tool. Then you have your AI application. It will have MCP clients to talk to these MCP servers. And then each client will have a one-to-one connection to the MCP server that it wants to talk. And then this whole thing of the AI application with the MCP clients, it's called MCP host. So if you hear about MCP host, it basically says an AI application that has one or more MCP clients. So that's the picture that we have after MCP. As you see, it's more complicated than having this one-to-one integration between your AI app and tools. But hopefully, with this complexity, you will get reuse. So your tools will be able to be reused by any application that has MCP client, basically. That's the whole idea. And in terms of how the communication happens between your MCP client and MCP servers, so if you are talking to a local MCP server, then you would be using what's called an STDIO transport, so this standard input and output transport. But then if you're talking to a remote MCP server, then you will be using streamable HTTP transport. And you can also use that for locally running MCP servers as well. I think there's also an SSE, server sent events transport, that you might see in MCP documentation. That's a legacy one. I mean, they have it still, but I think going forward, streamable HTTP is the one that's supported. And you can actually, so if you see HTTP in the transport, it refers to streamable HTTP. And what goes over the wire is basically messages, and these messages are JSON RPC 2.0 messages. All right, and in terms of libraries and tools, there are SDKs for different languages for MCP. And for Python, there's a library called FastMCP. That's the one that I recommend to use because it's the easiest library that I found that you could use for MCP. But confusingly, if you look at the documentation of MCP, they use the outdated version of FastMCP. So if you see this import from MCP server, FastMCP, this refers to FastMCP 1.0. It works, but it's not the latest one. Instead, you should really use FastMCP 2.0, and you would know this if you have this import. So if it's like from FastMCP, then you know that it's the right FastMCP library that you should use.
So it's the 20 squared
annotation.
Yeah. It's even better.
And there's a tool called MCP Inspector. It's a web-based tool to help you debug your MCP servers, whether they are running locally or whether they are running remotely. So it kind of looks like this, and I'm actually going to show you a demo of this shortly. But basically, you choose your transport type, streamable HTTP or standard IO, then you point to your URL. First, you need to connect, so you click connect. Then after that, you have access to the MCP server with the tools, prompts, and resources. Then you can list the tools, and you can look at the list of the tools. Let's say you want to choose this one, then you can choose it, and then you can actually also run the tool. So you can pass in the parameters and run it and get the response back. So it's very useful for kind of debugging and testing your MCP as you kind of work on them.
Yeah, and I highly recommend you. It's like a remote API. It's always good to play with it, with those sort of tools before you start writing your applications. There might be some idiosyncrasies in the interactions. Better you're not suffering from within the coding of your app.
And just because we said we'd be using Quarkus, actually, you don't see it in the URL, but it's a Micronaut MCP server. So I just wanted to plug a Micronaut in there.
We like Micronaut and Graham too.
So all the major frameworks in Java support MCP to some extent, but we'll come back to that. It's an important point in the conclusion.
Yes. And in terms of MCP support, you would find different levels of MCP support in different tools. Like, for example, Google has something called Gemini CLI, which is a CLI tool to have an agent within your CLI. I use that for basic overall MCP testing, and it works pretty well. And I'm going to show you some examples of that shortly. If you are building agents, then there's Agent Development Kit from Google, which has a Python and Java SDK, and ADK supports MCP tools only. So if you just want to do MCP tools from an agent, ADK works, but for everything else, they don't have support. Cloud Desktop is good for testing local MCP servers, and it helps you to kind of, test them with natural language, and I'm going to show you an example of that as well. And then LangChain4j supports all MCP. Well, not all, but at least the tools, resources, and prompts. So depending on what tool you're using, you need to check what kind of MCP things it supports. It's not always everything supports everything else, which is not true. So if I have to summarize, this is basically what I tried and what kind of works. So Cloud Desktop is for local MCP servers, and it supports all the tools, resources, and prompts. Gemini CLI supports both protocols, but it only supports tools and prompts, but not resources, although the resource support is being added, I think. ADK only supports tools, and LangChain4j seems to support everything.
Just to be clear, the former two are really tools, end-user tools, right? And the latter two are like frameworks to write applications, agentic applications on top of.
Exactly. And why are we listing these and nothing else? Because these are the ones that I tried. And what I observed is that there's different levels of support in each. So I just want to point that out so that if you're using another framework, make sure you check what kind of MCP support it has. All right, so let me actually now show you some examples of this. So if we go, and I think we're going to share these links at the end of the presentation, but I have this repo where I basically put together like a walkthrough of different MCP scenarios. First of all, we'll be talking a lot about MCP server, how to build an MCP server, how to build an MCP client. But for most of the time, you're not going to actually build MCP servers. You're going to use an existing MCP server. And that's the whole point of MCP. Ideally, by having the standard, like you're going to rely on someone else's MCP server and use that to do things. And that's what I want to show you first. How do you use an existing MCP server before we talk about building your MCP server? Now, in terms of how do you use an existing MCP server, let's say there's a lot of different MCP servers that you can use. But if you go to this references page for MCP, you can get links to the SDK, but you can also see that there's a bunch of reference servers. One of them is file system. So this is a file system MCP server that basically gives access your model gets access to the file system if it uses this MCP server. And you can use this from different places. So let's look at, for example, first using MCP inspector and how we can use MCP inspector to use this. So to use MCP inspector, you can just run it with npx. And then you can also pass some parameters. So here we are saying, OK, start the MCP inspector and start and use this server file system, and then give access to this file system. So I'm basically giving it access to my desktop. So let's actually copy this, come back here, and start this up. So usually, as I said before, I start with MCP inspector and make sure things work here. So as you see, I choose the standard I/O protocol, and then the command and the arguments are already filled. Then I need to connect. So I connect. So this starts the file system MCP server locally. So we don't have to start it separately. Here, the MCP inspector actually starts that for us. Then from here, we don't have resources or prompts in file system MCP, but we have tools. So we can list the tools. And you can see that these are the tools available to our application now, like reading a file, writing a file. So all the file system things that you would expect.
Files could have been exposed as resources, right? Potentially in the implementation of that MCP server.
Yeah. And let's choose that create directory, and then we can say users, HTML, desktop, and then let's say MCP test. So if I run it like this, you see that it says it ran, and then you can see my desktop that I have this MCP test folder that's created. So now we can do all sorts of things with the file system. So that's one way of testing an MCP server. Now, let's close this. We don't need this anymore. Let's close this as well. Let me get rid of this because I like my workspace clean. All right. The next one is, like, let's say you want to use Cloud Desktop, and then Cloud Desktop can access to MCP servers running locally. There's this quick start. I won't go through this, but basically it shows you how to set up Cloud Desktop with local MCP servers. I already did that, and then if I open Cloud Desktop, you can see that I have this file system MCP server already enabled. So then I can do things like, write a poem about a tired software engineer and save it to desktop as poem.txt. So let's see if this works. So now, since file system tool is already set in cloud, then it will ask us, this is a good thing, and can I actually save this on my desktop? And I'll just say allow once. And then, as you see, it created this file, and then we can see that the where recorder has like LEDs at 3 a.m., blah, blah, blah. So it created this and saved it to the desktop. All right.
But you have to read it with a nice voice.
But it started like you, Guillaume.
You want to do it? And the beauty of MCP servers is that once you have it, then you can use it from multiple places. So we used it from MCP Inspector, we use it from Cloud Desktop, but we can also use it from Gemini CLI, which is Google's coding tool that works from the CLI. The way you can add MCP servers in Gemini CLI is that you can create this Gemini settings file. And in this settings file, you basically specify how to start this MCP server. Or alternatively, you can also say Gemini MCP add file system, and then add the parameters that it needs. And then this will add that configuration. But in the end, you basically have a settings file that will look very much like how you would set this up in MCP Inspector or Cloud. That basically tells Gemini CLI how to run your MCP server. So if we go back here and then to Gemini, now this will start the Gemini CLI. And then now if I do MCP list, then this shows me the MCP servers available to my Gemini CLI. As you see, there's the file system MCP server that's already available to me. And then I can say, like the same thing that I said before, let's just say, just copy and paste this so you don't have to see me typing. But basically, I'll say, can you create a directory named MCP Gemini? And then Gemini CLI should use file system to do that. Although this is not a great example probably because Gemini CLI already knows how to deal with file system itself, but let's see what happens.
It's funny when you have like native support and tooling support. You can see sometimes it uses the native one, sometimes the tools.
Exactly.
It's the LLM choosing it. Right?
Yeah, that's what I'm waiting now. Like selecting the tools is let's see if it's gonna try to handle that natively or it will try to use the. But it's taking an awfully long time. Yeah. There we go. And then it says, yeah, it's using make directory, which you would expect because why would you use a tool for something that it has access to? But sometimes it will tell you, can I use the file system one? Okay, so let's kill this for now. And the last one I want to show is agent development kit. So if you're building agents, then you can use ADK from Python or Java to build an agent. And then these agents can also have MCP support. And just to show you the code quickly. So I define an agent. And then I'm just saying, OK, these are the instructions for my agent. You are a file system agent that you kind of help me to manage my files. And then I pass that instruction here. And then the important bit is that under tools, we have this MCP tool set. And then here, you basically specify what kind of MCP server you want to talk to, local or remote. In this case, local, because we are using standard I/O. And then the command and the arguments that you want to run with. And then you can also filter the tools if you want, because sometimes you want to give access to the MCP server, but maybe not all of its tools. So you can do that if you like. So by doing this, you are basically giving access to the agent, the MCP server that you want to have access to. So let's run this as well. Let me see. Yeah. So if I do ADK web, this is a web-based tool that you can use to test ADK agents. So if we open this, then I can choose my file system assistant, and then I can let's see if it works first. Hi. Okay, and then it tells me, can you help me to manage files today? Please create a poem about software developer and save to desktop. And this time we are doing the same kind of thing, but from an agent. And all of this can be done from Java as well. And yeah, so it created this poem. You want to read it?
A shorter one.
Yeah, it's a shorter one, yes. All right. Cool, let's kill this.
Roses are blue and no, what was that? Never remember.
Yeah, so I think that's all I wanted to show here. Let me go back to my slides. Yeah, so I already showed you the MCP in ADK, so you wrap it into this MCP toolset. And then there are MCP registries. So recently, I think just like a few weeks ago, there's this open source MCP registry that you can go, and then it lists basically all the MCP servers available to you. This is about discovering MCPs. But then GitHub also announced their own MCP registry, which supposed to wrap the open source one, I think, but I'm not sure. And I don't know why we will have two, but the GitHub one seems to have a nice UI that I like to search things. But so yeah, these are the two registries that I know. I don't know if you guys know any other ones.
No, but the things to know is that this spec is moving very fast. So you probably have been doing something on your side. I know we have done something on our side, and the spec shifted into a very different direction, removing essential pieces. So it's still a bit very early. So you will see those. That's good for exploration. Let's wait for the standard, the spec to settle a tiny bit.
But in the announcement of the GitHub MCP registry, they mentioned the actual open source MCP registry from the model context protocol. So I'm not sure if it's like maybe an extension or something like this. It's not very clear to me.
Yeah, I mean, that was my understanding as well. But then when I searched some of the open source MCP things, I couldn't find them in GitHub. Maybe I didn't search properly, but yeah, I'm not sure. All right, so that's MCP kind of intro, but then let's get into MCP servers. Like, so if you want to build MCP servers, there are 3 different things that you should care about: tools, resources, and prompts. So let's take a look at them quickly. Well, first of all, when you're using MCP, there's an initialization that happens under the covers. So you have your MCP client that will send an initialization request with protocol version, capabilities, and client info. And then the server will respond back with its own capabilities and server info. And then once that happens, then the MCP client will say, OK, we will send a notification saying I'm initialized. And then the whole communication will start. Now, this usually you don't need to care about this because if you're using a library, this happens under the covers. But it's good to know that there's this initialization that happens under the covers. Now, the first thing, and maybe the only thing that you would care about MCP is the tools. Basically, tools enables AI models to interact with external systems. It's a function with inputs and outputs. And then the model chooses when to call tools. I think that's the key thing to understand. It's the model that's deciding, based on the context, which tool should be called. Now, in a nutshell, what happens is that when your MCP client starts up, it will ask for the tools that's available from the MCP server. The MCP server will respond back with the list of tools. And then at some point, the client will decide, OK, can you please call this tool? Then the MCP server will the tool will be called, and the MCP server will go to the third-party external thing to get the responses back, and then it will send the response back to the client. So that's what happens in most of the time. But what happens under the covers is a little bit more complicated. So there's this good flow from the Anthropic website that I want to go through. So what happens is that, let's say a user comes in and says, what GitHub repositories do I have? Then we have our server that has its MCP client, that talks to an MCP server. So the first thing that will happen is that the MCP client will send a list tools request to the server. The server will respond back with the list of tools. Then the server will say, our server will say, OK, this is a question that user has, and these are the available tools. So that will be sent to the model, in this case, Cloud. Then Cloud will decide which tool to call. So it will say, can you call this tool? And then our server, through the MCP client, will call the tool. Then the MCP server has integration with GitHub, so it will make the request to the GitHub, get the response back, and then it will return the result back to the server via the MCP client. And then finally, we pass that back to the model, and then the model will respond back with your repositories are, and then it will list that, right? So as you see, it's very similar to what we used to have with traditional function calling, but except we have this MCP client and the server in the middle, that's kind of standardizing what happens over the wire so that it's standard for everyone. So that's tools. Now, how do you create tools? This is Python. And in Python, as I mentioned, there's fast MCP library that you will use. So you will create a fast MCP server. Then you have your functions. Here I have this hello world functions. Obviously, you will have something much more complicated. But if I have a sum function, then I can just annotate that with MCP tool, and then it becomes available as a tool, basically. Or if I have a get weather function, then I can just annotate it, and it will be available as an MCP tool. Well, maybe I'll show this quickly, and then we can talk about Java. So if I... So close, yeah. I just wanted to...
I wanted you to jump in.
Make sure you're not sleeping.
You should my slide. Come on.
So for example, here I have my MCP server. So I'll just show you quickly. As you've seen, I create my server, and then I have my two functions. And then you start your server. You can choose standard I/O. So if it's running locally, you can choose this transport. But then you can also choose HTTP, which is streaming HTTP, basically, running locally. And then once you have that, you can have a client as well. So for example, here, I have a client that points to the server. And then with the client, I can list the tools I have. And then I can also call the tools with the parameters like greet and so on and so forth. So let's actually run this quickly. So let me see. Create local MCP. So I start the server. So it's running. And as I said, the first thing I always try is to test it out with MCP inspector. So I can come back here and then start the MCP inspector running locally. And then this time I think it's streamable HTTP. If I connect, you see that I'm connected. And if I list the tools, I can see my add and greet. And let's just say, let's greet Guillaume. run the tool, and then I can see that I get the result back. So I know that it's working, which is great. Okay. And then what else I want to show here? And then, yeah, I mean, as I mentioned, you can also write a client to run against it. So if we go back to here, Python client, now this will, it will list the list of tools, it will list them, and then we can also call it and get the result back, and so on and so forth. So this is all running locally, and we can just test it like that. Now,
I wanted to jump in, but you spoiled my, my action. So what about Java, right? I think there are quite a few Java developers here. So I wanted to illustrate what you can do also from Java. So first, I'll show just the client side with ADK, but with LangChain4j, it's very straightforward as well. So here I'm saying, OK, I want to use this MCP server. So I deployed that on Cloud Run, which is a Google Cloud product for serving and scaling containers. And this one is actually using server send event. So this is the one I developed with a Quarkus, so I'll come back to it. I create a tool set. It's a different syntax from what you had in Python, but we create also a tool set, and we get the list of tools that are available in that tool set corresponding to that MCP server. And then at the bottom, so this is an MCP server which calculates the phases of the moon. And here I say, OK, here's the moon phases tools that are at your disposal for knowing more about the phases of the moon. And I'll show, so I did two implementations. I did one in Quarkus, where I have a calculation service that does the computation of calculating the phases of the moon. And then I have two tools, one that gets the current phase of the moon, so I don't need to pass any parameter. And just like oops, sorry, I went too fast. And just like with so you also had annotations in, well, equivalent of, it's decorators in Python, but it looks like Java annotation because there's an @ symbol. So similarly, I say, OK, this method is actually a tool. You can use it for describing the current phases of the moon. And here, the other method also takes a parameter. So in addition to the @tool annotation, you also have an @tool arg annotation that describes the particular input parameter, this request parameter. And then I can also handle the things like validation of inputs and things like that. And I also developed one, so I mixed the slides, so we'll have to come back to that one. I put it in the wrong order.
Okay.
So I'll tell you for later. So I'll take back the lead on this. In Micronaut, thanks to my friend Sergio, I don't know if he's in the room. He was talking about MCP with Micronaut this morning. We did this, so I did the first implementation, and he sent me a pull request, which improved my solution, because it really streamlined things. So it's similar to Quarkus in the sense that you have @tool, and you don't even need to say, so there's also a tool arg annotation, but here it's using the built-in validation of Micronaut, so that you can add special annotations like @valid, so that it validates. So I'm not showing the moon phase request object, but it validates the input. So for example, if I didn't use the ISO 8601 standard for dates, it would have said, well, it's not valid input. I need valid input. So I don't show you the rest of the code, like how the moon phase request is done. But what's nice as well is that we use rich type safe objects. So we're not manipulating JSON payloads or things like that. It's really typed Java object. So I've got a moon phase request, moon phase emoji, because I return the phase plus an emoji. But yeah, that's it.
Cool. Thanks for the Java detour.
Yeah.
So am I in the right place now? Yes. OK, so that's tools. The next thing in MCP servers is what's called resources. Resources, they basically provide read-only access to data. OK, and of course, you can also from tools return data if you like, and you don't have to use resources. But I think the spec basically they wanted to have something that for read-only access to data to provide as context to models, and that's what resources are used for. Yeah,
I think in the spec, when you read it, they say that tools are for the the LLM to decide, right? But resources are for the client to decide.
Right.
They don't say it. My intuition is what they had in mind is RAG, where they would say, okay, the client asks for a set of resources like files or documentations or something like that. Fetch that information, do some RAG magic on it, and then send the contextualized information to the LLM, right?
Yeah, that's my understanding as well, and I'll mention this shortly.
Sorry.
It's okay.
Spoiler again. Okay.
And it's in Java. No, I'm kidding.
And the way you would define this is basically, for example, let's say you have a document, then you can define an MCP resource and just point to the name of the document, or maybe you have a configuration that you want to expose as a resource, so on and so forth. And then the last thing that MCP servers might have is the prompts. When I first heard about it, I'm like, why would you expose a prompt through an MCP server? But then when I started playing with MCP, it kind of makes sense, because you have your tools, you have your resources, but then the user has to know how to call those tools, how to call those resources. So prompts basically provide a way to tell users, okay, this is how you can call these tools. So by just picking a prompt, you are basically telling the user, this is how you could call the tool with these parameters, and it kind of gives a way to tell the users how to best use your MCP server. And I'm going to show an example of this in the next sample. Yeah, so the way you do prompts, the way you do everything is basically define a function and then just annotate with the prompt. So here we have a couple like code review or debug assistant, but typically you will have more complicated prompts. So these are just simple examples. So let me show you an example of this. But before I do that, let me recap what you said. So the tools are basically model controlled, right? The model decides if a tool has to be called or not, and they allow LLMs to interact with external systems. Resources, I think the MCP website says app controlled, but I would say it's app or user controlled, because user basically decides what resource to add to the prompt. So I think it's both. But the key thing, I think, with resources is that they're just read-only access to data, right? Any kind of data you want to read and provide as context, you can do that through resources. And prompts is the same way. It's user-controlled, so user decides which prompt to call. And they provide kind of like a template on how to call your MCP service. So yeah, that's my understanding. And then in terms of an example that brings all of this together, I created this document server. So let me show you that quickly, and hopefully this will kind of make sense. So I have this document server that has tools, prompts, and resources. But just to show you what it's supposed to do, so I have these text documents, like let's say this text file or spec. And I want to kind of give users a way to format these texts into Markdown. So I can do that with an MCP server. And in this server, I have a tool, read document. Then I have another tool called edit document that's basically given a document ID, an old string and new string. It replaces the old string with the new string. So it just edits the document. Then I define two resources. List docs resource, because maybe you want to see the list of documents in my application. So that's a good resource. And another one is a resource to actually get the document. And then, yeah, the cool thing is, okay, now I have these tools and resources. Now let me have a prompt. So I call this prompt format. And this prompt rewrites the contents of the document in Markdown, basically. And here I define my prompt. And I just say, your goal is to format a document to be written in Markdown syntax. This is your document ID. And then I just give some instructions on, add in headers, bullet points, tables, etc. And then I can also say, use the edit document tool to edit the document. After the document has been edited, respond with the final version of the doc. Don't explain your changes, so on and so forth. So we are providing instructions and kind of best practices, like don't explain your changes within this prompt. And then users can use this so they don't have to kind of figure out how to use our tools. So that's the idea with prompts. And the way we can use this, let me go back to my instructions. I mean, you can use this from anywhere, but I think Gemini CLI has a cool way of using prompts. So if you add this to Gemini CLI, this document server, then the tools and the prompts become available to you. And then you can use prompts as commands, basically. So once you have this format prompt, then you can say format and pass in the document ID, and it will just work. So let me just show you that. So let's go back to document server. And then let me see. Yeah, I had the Gemini already in there. So if I start Gemini, yeah, I don't use Gemini CLI too much. Like some of my teammates, they use it much more than me, but I really like it for MCP testing. So if you
can do much more, you know.
Yeah, I know. I'm just more an IDE person where I like to edit code in the IDE rather than CLI. But I mean, I know it does a lot of great things.
And there's an integration with your IDE anyway.
Yes. So yeah, if you do MCP list, you see that we have the document server, but it's disconnected. Because I need to. I need to start it. The best way is disconnected. So let's. Let me stop this and go back. Document server, Python server. Okay.
Sometimes MCP, STDO, MCP tools work standalone. They serve themselves. But in this example, you have to start a server before using the MCP tools.
Yeah, because I think this is using streaming HTTP.
Yeah.
That's why I think we need to start it. Yeah,
STDIO is a slave, so it's the client that starts the server. Is in control of the lifecycle, whereas in Streamable, it's a web server, so you don't control that.
Yeah, and as you see, I have the tools available to me, but then I have the prompt, and then if I do format, then you see that Gemini CLI recognizes that this is a prompt, and then it's telling me, oh, you need to enter document ID. So let's do that. Document ID, and I think I need to point to one of my text files, so spec.txt is one of them. So now, hopefully, it will recognize that, this is a prompt, and it's asking me, can I use this MCP server, and can I use this tool read document contents? I will say allow once. You can do allow all the time if you like, but I'm always nervous for what AI can do, so I will always be there approving things. But now it read the document, it's a text file, and then it should. Now it's asking us, can I edit the document? Can I use that tool? I'll say allow once again, and now it will do the markdown, and then it will save it. And then one more time, because we told it to display us the result, so yeah, it displayed us the result. As you see, it's marked down now. And then once it's done, I think it should be done now. So if we actually look at it, git diff, you see that the spec.txt was edited with markdown. But the nice thing here is that we have the prompt to do this, and all the details of which tool to call and everything is done via the prompt. So that's why they kind of make sense to me now after I worked on this sample. And then eventually, I mean, all of this stuff that I show you is like MCP server running locally, but eventually you probably want to deploy it somewhere. Cloud Run is Google Cloud's container platform, let's say. And I think it's a great place to also deploy MCP servers, because typically you would have your agent running in Cloud Run on ADK probably. And then once you have that, you can also deploy your MCP servers on Cloud Run, and then they can talk to each other. And then with that, with Cloud Run, you get scalability out of the box. You get a centralized server that not only you, but your teammates can use as well. And you also have authentication already done via Cloud Run. So I think if you're on Google Cloud, if you're running your agents already on Google Cloud Run, then having them over MCP server, having your MCP server on Cloud Run is also a great great place to be. And I won't show you this, but I just want to point out that I show how to do this in my repo, basically. And the only thing that you need to do is when you create your MCP server, Cloud Run requires that you bind to 000, and then you bind to port environment variable. So that's what you have to do. And then once you do that, you can just deploy to Cloud Run, and then it will just work. And then your MCP inspector, all you need to do is just point to your Cloud Run instance, and then you will be able to test it with MCP inspector. And then if you need to do authentication, you can also do that and I explain you how to do this here, but I won't bore you with the details right now. All right. Okay, so that's the basics of MCP server. Now, there are other features in MCP. I think these are listed as client features, but I don't think they're MCP client features. They're more like MCP client and MCP server features because they kind of work hand in hand. And I don't think many tools support these yet, but if you're building MCP clients yourself, or if you're building your MCP server yourself, then they might be helpful. So that's what I want to, that's why I want to mention you now, like these different features, so that you're aware of them. The first one is called routes. Basically, it's a mechanism for clients to communicate file system access boundaries to servers. So let's say your server has to have certain access to the file system. You can do that through routes. The way you do this, from Python at least, is that when you create your client, you just point to the routes, and these are the routes that will be available to the server. Or you can do it dynamically as well. So you can do this callback, and then you can update it basically afterwards, pointing to the routes. So that's kind of all there is to it with routes. Another one is called elicitation. It's more interesting than routes. Elicitation enables MCP servers to request more information from the client. So things like approval. Let's say something has to happen and you need to get approval from the client, or maybe you call the tool, but the tool doesn't have all the information. Then you can ask the client, can you provide me this more information? Or maybe you need some kind of clarification. So for those kind of things, the server can basically ask for more information from the client. And the way this works is that the MCP client makes a call to the tool, to the server. Then the server at some point decides that it doesn't have enough information. Then it will create this elicitation message. Then this will go back to the user, and then you will display some kind of question to the user, like what the server is asking for. Then the user will provide that information to the client, and then the client will pass that to the server, and then the server basically will have the information it needs. It will make the tool call, and then it will return the response from there. And this elicitation doesn't have to be just one. You can have multiple as well. Like you can have this as many times as you want before you make the tool call. So just to show you the code, so let's say you have this MCP tool, and then the request comes in, and all you want to do is, before you do more things in the tool, you want to get the approval of the user. So what you can do is that you have this context object, and you can just say elicit, and then pass in a question, and then here the response type, there's no response type, so the user has to either say yes or no. So this will go back to the client, and the client will send the approval back, and then we'll have the result back, and then if it's accepted, then we'll continue, otherwise we'll decline it. So this is the easiest elicitation request that you can have. This is the server side. On the client side, what happens is that the client has what's called an elicitation handler, basically. So here, when you create a client, you say, if you get any kind of elicitation requests, then pass it to this function. So it goes to this function. Then we print what the server says, so the question of the server. We get the user input. In this case, I'm just doing this from console, so this is what the user input is. And then if the user says no, then we say action is, the elicitation result is declined. Otherwise, we'll say accept. And I have a bunch of examples here, so maybe I'll show you just a couple. Elicitation, yes. How are we doing with time, by the way?
We're consuming quite a bit. So.
Huh?
I think we're consuming more than we expected.
Okay, so I'll wrap it up quick then, yeah? Or
if you want to give a break do you guys want a break?
No.
Oh, okay. So who wants a break? Okay, a third of the room. So
I think we will continue then.
Yeah. I just finish this part so that we do the break.
Okay, so let me wrap this up quickly, and then we can do a quick break, and then continue with A2A. So just to show you this, so I have, for example, approval action. So this is when the server when the client just approves an action. But then we can also do more complicated things, like, for example, we can ask the user, like response type is a string, so we can ask a string from the user, or then we can do like certain constraint responses. So let's say the response has to be like low, medium, or high. We can do that. Or we can even do like structured response. So we have the user info, for example, that we are looking for, and then we can ask the user info from the client. So just to run this very quickly, elicitation. Let's start the Python server, and then if you run the client, then I have this like, sorry, that's what happens when I start rushing. So yeah, if we do this, for example, if we select the approve action, then the server now tells us, do you approve this action? Then I'll say yes, and then the result will be the action approved. But let's do something more complicated. If I want to plan a meeting, then the server can ask multiple things from me. So I can say, what's the meeting title? DevOps. And then duration in minutes, 60 minutes. Is this urgent? Let's say no. And then now the tool can be called with the right kind of parameters. Okay? So that's elicitation. And the other one, I won't show you the example, but I'll talk more about it, what it is. The other one is called sampling. And the idea of sampling is that the MCP server can ask the MCP client to make LLM calls on its behalf. Okay? And you might be wondering, like, why you want to do that? Because server, like, you have the integration with the MCP client and the LLM already. So one option is you can also have integration between server and the LLM, but you don't have to. By using sampling, the server, if it needs some kind of LLM response, it can ask the client, can you please call the LLM for me for this? And the client can do that. So that way you can have integration with the LLM in one place. And also the other benefit is that the client integrates and pays for the LLM usage, so you don't have to worry about server getting overwhelmed with all these LLM calls and all the cost that comes with that. And you can also have a human review in the middle. So as this is happening, you can have a human in the MCP client kind of approving or not approving these LLM calls. So that's the idea with that. And the way this works is that the server, whenever it needs something, it will ask the client, then the client will ask a human if it needs to, then it will do the LLM calls, it will get the response and send it back to the server. And I have example of this. Let's say you have a generate code tool from MCP server. Then to generate code, you want to use a large language model, but then you can basically do this sampling. So we will get the context again and then make this sample call, and then we will say, okay, this is my prompt, write a Python code example demonstrating this concept. This is system prompt. You can specify the model preferences as well, and some other model things like temperature and max tokens. Then this goes to the client, and then the client will get it as a sampling handler, and then it will get the sampling message, and then it will do the call to the LLM on our behalf, get the response back, and then return that back to the server. So that's the idea. And last but not least is that progress reporting and monitoring. So all these LLM calls and things, they will take time, but then you can do progress reporting from the server, and then you can display that progress from the client. And this is what this is about. But the way this works in the code is that, again, you have the context, and then if you need to report progress, then you can do progress reporting by percentage or by time and things like that. But you would basically just report the progress. And then on the client side, you will have a progress handler, and then as you get the progress, you can decide what to do with it. You can display it or just ignore it, whatever you need to do.
Kudos to somebody that does the Windows-style progress bar that goes back in time. Remember 95?
Yeah. So for all of this, the sampling and progress reporting, I have samples in my repo, but I won't show them now. But feel free to check it out in my repo.
All right. So let's take a 10-minute break. Just come back at 3. And we'll go with A2A in details, showing the codes and live usage of it, and of course explaining the protocol. See you there. Okay, so let's get started again. We're going to talk about agent-to-agent protocol, also known as A2A for the friends. By the way, please give us feedback hopefully good, but give us feedback. I think it's within the app that you can give feedback, and you can do it now. The next will be even better, so don't worry about that. No, I'm kidding. It's super useful for us to get feedback. So,
yeah, and in the tool, we can put the slides. So I'll put the slides at the end of the, the presentation.
Cool. So A2A got started by a few folks at Google, but they realized because they wanted to deal with an ecosystem, they started to work with industrial partners very early on, and they made something really good, which was to move the ownership of the protocol to the Linux Foundation, which is always a better solution when you want a protocol to really catch fire, to move it to a neutral ground so many people can actually work on it, versus having one master and then everybody's like wondering what could happen. So what is A2A really? So Guillaume told us about agents. Remember, they are goal-oriented, hopefully autonomous, and they react with their environment. So they are really the link between LLM and the reality, maybe a state change, maybe a user feedback, or things like that. So that's an agent, that's a blue box. And in practice, agents are actually written of lower level mini agents, and you tend to use an agentic framework. So we've talked about Quarkus, LangChain4j, we've seen ADK, and there are plenty more. And of course, there is an LLM to work on it. But when you want agent to talk to another agent, that is not within the same application, but remote, that's where A2A is for. It's really a protocol to communicate between various agents. So you have three high-level concepts. The end user, which is you and me, even though technically A2A could be used as without a user, in the middle. I can imagine use cases coming that way, but later. Then you have a client, which is the agent that is coordinating or in need of various sub-agent operations. And then you have one or several servers, sometimes also called A2A remotes. And the protocol gives us technology agnosticity from a communication point of view. So, I'm a Java guy. I did code in C# back in the days, so that's why the smiley. But initially, I put COBOL, but there is no SDK for COBOL. So
not yet.
Not yet, I guess. So you could have an agent in one language, one platform, and then another platform, and a third platform, and all of them will work nicely together. That's the idea. So why would you want to use A2A? There are like three values that I see, but the most important one is the interoperability. As I was mentioning, you can use different platform or even different framework within the same language or things like that. They will be able to interoperate because the protocol is agnostic from that point of view. The other interesting thing is you then can build a set of agents and move the level of experience you're having by essentially building composite AIs, right? Instead of having one agent that is controlling everything within its own local sub-agents, you really have a composable ecosystem of agents that works together. We'll talk about that a bit later. So interoperability is very important, and the problems that interoperability is trying to solve is, what is the agent? What is it doing? How can I find it? How do I communicate between one agent and another? What do they speak, really, right? And then if it's a ad hoc one-to-one, like how do I scale from not just one communication with another agent, but one communication with 3, 4, 5, 10, 20 other agents, right? So how do you scale at those levels? And of course, how do you keep stuff secured? We haven't talked a lot about MCP securities because
the MCP stands for security.
Exactly. So which is a big problem, right? So you see other people in MCP doing ad hoc security, but in A2A, we'll see that it's actually built in. The other two values is to move in complexity of the workflow. So those sub-agents, there is essentially a way to handle the state management and coordinate them thanks to the protocol. And that helps you, delegate various subtasks into and exchange information in a way that makes the system potentially more complex without making it, more advanced without making it more complex because you keep stuff isolated. And that leads me to the last point, which is secure and opaque. Okay, that's 2 points, but I've cheated a bit. But the opacity, so an agent from the protocol point of view is the black box. It has a very well-defined entry point and output, and you define what you want there. But the rest, the context, which LLM it's using, what other resources it's using, it's opaque, which means that if you have to change one agent with another and swap it, you don't have an impact on all of the other systems. And sometimes it's very useful to share memory, and local agents tends to do that thanks to the agentic frameworks that they are using. But here we're talking about isolated pieces. And the complexity of the workflow enables unsiloed universes, right? So what would it be for? So first of all, much more advanced application that would be able to essentially, you build a set of advanced agents within a given context. Let's say I've got an inventory system, a logistics system, a procurement system. They all have their agents, but then I want a higher level agents that coordinate all of that work, right? That's what you will be able to do with A2A and keeping it opaque. So it is unsiloing your ecosystem. So that's one way. And the other way is, imagine you have an ERP system like SAP, and they offer an agent-to-agent, protocol. You could use that agent from your higher level or business-specific agents and really coordinate and call the various agents to make a bigger and more advanced systems, out of it. So that's where the cross-platform and cross-vendor aspect is interesting. So I've been in the industry long enough that the whole, hey, thanks to this standard, everything will be an ecosystem and life will be awesome. Like, I don't know who remembers EJB, which was supposed to be an ecosystem of business components. Yeah, didn't go too well, right? We'll see about this one. It might actually end up being something with legs, but let's see how it goes. And yes, it's a bit of the SOAP of agents. I know SOAP has a very bad rep, so let's imagine a good way to interact. And I'm not saying REST, because I think it is more structured than REST. So I think it is more SOAP, though it's less complex than SOAP, let's say. All right, let's go concretely into the protocol and how it looks like. First of all, you need to describe an agent and discover an agent, right? And to do that, you have a JSON file that has a very well-defined set of properties that will let you define the identities, whatever capabilities of the spec the agent supports, right? A bunch of capabilities are optional in the spec. You've got the endpoints, and you've got skills, which are like functions or well, that's unfortunate things. I would have called it capabilities, but skills are like features that the agent is able to achieve, right? And of course, the authentication. So if we look at the JSON file here, you see a name. And it's really important because the name will essentially be a key information for the client agent to decide to use one agent versus another, right? Especially if there is a notion of supervisor and the LLM is choosing which sub-agent is to be called. We'll show that in the demo. So the name and the descriptions are really important. Then you define a transport. Here I'm using JSON RPC. We'll see that they are alternative. Then you can have multiple transports. And then there are like capabilities. The spec at least defines the notion of streaming, the notion of push notification, the notion of history. Here, two of them are enabled. And there is a security scheme, and then the security, how it's enabled within the agent and the interaction with the agent. The good thing is that they are reusing, for people very familiar with OpenAPI 3.0, that's the security scheme and the security objects that you have within OpenAPI. So they're reusing that. And of course, an agent got inputs and outputs. And you see here that you can support various types of input: plain text, a data structure like a JSON file, an image, a video, essentially any sort of MIME type, potentially. Next, you've got skills, which are the features that I was describing. And again, it's super important to have the name and the description on it. But the thing I really like is the examples, because for people that have played with prompt, you know that a few shot prompting is actually a useful technique to help guide the LLM into calling the right things. So those examples could be copied verbatim into your LLM to help him do the proper calls. Then you've described the agent, and it needs to be discovered. There are like 3 models, right? The first one is that file is actually under .well-known/agent-card.json. So .well-known is something you might be familiar with. For example, the ACME protocol, this is where they put the information to get an SSL for Let's Encrypt and things like that. So here is just another type of thing. So technically, I could scan the internet, look for every server with a .well-known/agent card, and know that there is an agent under that website that I could call. Okay? I'm not sure that would work. I don't see Google saying, here is the Google agent. That feels like a ginormous thing, right? So I don't know that the domain is really the right level of size of things. The second model is direct call. If you know the URL of the agent, then you can get the card, and then you can start the interaction. And that's what you will most likely start with. So you have a set of agents that are statically described in your application.properties, and then you can go and call them, right? And then the third point is the registry. So unlike MCP, the registry is not actually a thing yet, but they express the intent to have a registry to then look up the agents and maybe have a more dynamic API to fetch the right agent based on your needs. So OK, we have described the agent, and we've discovered the agent. Now, how do I talk from a client and a server point of view? You have essentially 2 main things. The notion of message. I'm asking something, and the server might come back and send back as a message, here is the response. And then you have a task, which is the higher level concept. It's something that could take a bit longer than just one request, one response, right? So it has a life cycle, and the client, thanks to the ID, can interact with that task, with the server. Artifact is really the result of whatever you ask of the agent. So it could be an image, it could be text, it could be a set of tokens being sent, et cetera, et cetera. And parts is just a technical thing where you can put several, out of the output, you can put several pieces underneath, and these are parts. We will see that more graphically here, right? So you have a message, which is coming from the user or is coming from the agent. And it's got an ID, identifier, and then within it, you've got parts, which could be one part or several parts, and then parts are of different types. It could be text, it could be a data structure like a JSON file, it could be a file part like a base64, a URI, and of course the name and the MIME type of the file. Okay? The task is, again, as I was saying, the higher level concept, and it's got a status, and we'll mention the status in the next slide. So it really defines the life cycle. And the task has a potential history, because the task can be long running. There can be several interactions between the client and the server. And optionally, some of the servers keep the history of the message that have been sent and send you that back underneath the task. So it's quite nice, actually, to debug. It makes the JSON a bit more ginormous, but at least from a, what do you call that? From a debugging point of view, that's quite interesting. And of course, you've got a list of artifacts that are the results that can be provided to the task, provided the task has been completed, right? And of course, artifacts are the end results. It's got a name, a description, and then parts within it. OK? Did I forget anything? No, I think I'm good. So as I said, the task has a notion of a life cycle. So when the client asks something of a remote agent, then the remote agent decides to answer right away with just a message, or decides to answer with a task. And if it decides to answer with a task, it will probably send a submitted information. So it's an acknowledgement that I've received your task as a server, and I'm sending you back the task ID, and I'll work on it. Okay? So you're submitted, and then of course you might reject it. Maybe you're too busy as a server, so you send back a rejected. And by the way, everything on your right, these are final states. So once a task reaches that state, it cannot be restarted. It has to be a different task. Okay, so that's the The spec is very rigid about that. They're like, we'll hit you with a stick if you do it or something. So, no, it's verbatim in it, and just look for it. Sorry, where was I? So submitted. Once you've submitted, you might either reject or you might decide, OK, at some point I will work on it. So I'm moving to the working state, and I might send these state changes to the client. OK? And once you're working, of course, you might fail, and you send that fail state to the client. Sorry, I couldn't make it happen. Or you might complete. That's great, because now you have the artifact within the task, right? And then there is another interesting state, which is cancelled. Cancel is an interesting state because that's the only one that's not coming from the server, but it's coming from the client. So I don't know if you've played with those desktop style or Gemini C. Well, actually, Mete played with Gemini CLI and used Control-C to stop a task. That's the cancellation. I don't want Gemini to continue doing the task in the background. So I'll say, no, I'm canceling and I'll do something else, right? So cancel comes from the client. You ask for the server to cancel, and it might cancel, it might not cancel, but at least it has the information to try and do it. And there are two other states that are interesting. The first one is input required, which is a bit like the elicitation in MCP. It's the task, while the server is working on the task, it realizes, you know what, I don't have all the information. You asked me to book a flight to New York from Brussels, but you forgot to tell me about the date. So I come back to the client, I say, what date do you want to fly? The client will figure it out, maybe ask the user, come back and say, OK, well, that's tomorrow. Whoa, wow, you're in a rush, right? And then the task will continue, maybe complete it, or maybe it will fail, OK? The other interesting state is auth required, which is, hey, you're asking the server to do something, the agent for a skill to do something, but you don't have the right authorization. So let me go back to you. Let me ask you to level up the authorization and then send me back maybe a JSON token to then continue the work security-wise, in a secured fashion. OK, good? All right. So let's go back to the interaction. The simple interaction, the one you see in a lot of basic examples, is this. The client asks a request, hey, what's the weather in London? Goes to the server. The server says, well, it's raining, because it's always raining in London. So you go back to the client, and then you give that answers, and then you've forgotten about everything, which means when you do a second request, the server has no idea that you came first to ask about London, OK? So that's by default. And that's a blocking sort of operation, right? Just like HTTP, and then you come back. With a task, the flow is a bit different. You still have a request. You ask for things. Then the task is created, so you move it to the submitted state, and you send that information to the client, so it could keep track of that. Then you're working on it. Then maybe you ask for more information, so you go back to the client and say, hey, give me more information about which city you want the weather for. The client finds that information, maybe in its memory, maybe via the user, send that back to the server chunks stuff, and then finally the task is completed with the artifact as a result, and we send that back to the client. OK? So which one should you use, right? The spec is flexible, in my opinion, a little bit too flexible here. They might have simplified the writing of clients if they had restricted that a bit. But message only is possible. You can always do things with just a message. Task only is possible, and that's the flow we've seen just right before. Every time I receive a request, I'll create a new task, come back, and the task ID will be propagated. So I forgot to tell you here, but the message more input is actually having a task ID that's propagated back to the server, so it knows the message comes for that task. Or you could have a hybrid model where you start with the message to get a proper understanding of the goal of the user, and then you start the notion of tasks. At the moment, and everything is changing because it's very new, but at the moment, I'm the kind of person that would prefer to create a task in a systematic fashion with the server. At least the interaction is more defined with the client, so the client can follow stuff more easily. Okay? But a task generally is goal-oriented, so that's super useful, and it it can be long-running, including async, and you can isolate context. So you can send specific information for one task, another specific information for another task. Let's say you're doing bookings, and you have two things to work on, right? Maybe the hotel and the car rental, right? And you can run those two tasks in parallel, and the context is really specific from a server point of view. They are isolated, okay? So that's a useful piece. There is one more thing you might have seen in a previous slide. It's context ID. So context ID is just a UUID essentially, or it's anything. It's a string, but that's supposed to be unique. That is the first time the client go and interact with the server will send back a context ID, and then the client might propagate that context ID for the follow-up conversation. So here what you see is that across tasks that have, like there is a first task here that is then finished, and then a second task, then the context ID can be propagated. So the server knows that those two tasks are related, or maybe those two messages are related, right? Because you don't have to use task here. So that's useful to say. Here is the overall scope of what I'm talking about. So it's a loosely coupled conversational state, except what you might ask yourself, or at least I ask myself, like, okay, but you have task ID or tasks, and then you have context. So when should I use what, right? So the task is very well defined with a well-defined life cycle and interaction. Context ID is pretty much undefined. It says, it would be nice if you kept the context. What you do with that context? Do you keep the state for how long on the server side? None of it is specified, right? So I think it's useful, but it's very underdefined. So I would go for task for very specific interactions. Okay, that was a lot of information coming in. Let's go into the lower level, the infrastructure, into how those high-level exchanges are actually happening at the wire. So you got 3 protocols, well, just like MCP, but different, except the first one, I guess. So the historical one is JSON RPC2 based. So you're using HTTP, or more specifically HTTPS. And then you pass the messages, you pass the interaction via this method call based payload that is JSON RPC 2.0, right? So JSON RPC is really just, here is the method name, here is the payload, so my parameters, and then you get results back. So that's what it's about. There is a second protocol that came after, but rather quickly, is gRPC support. So gRPC is very much method-based call as well. Of course, the semantics, not the semantic, but the conventions are a bit different. So you see the method calls are slightly different between gRPC and JSON RPC, but that's just details. And the new one got added, which is JSON HTTPS over with JSON, HTTP and JSON over REST. And here it's more like RESTful, right? So you literally use the URL for the verbs and things that, not for the verbs, sorry, for the actions, and then the verbs will be get, post, etc., etc. So that's one level. You can do streaming. All of those protocols, by the way, are semantically equivalent. They're supposed to be interchangeable. All of them have streaming, so using SSE for the HTTP ones, and using the natural gRPC streaming for gRPC. That's a way to just send part of the information. Let's say, the classical experience with an LLM is you don't ask a question, go and wait 3 minutes and get a blob of text right away. You get the beginning, then the next, maybe it goes back, and then, right. So you have an interaction. So you can send part of the message, part of the result, and you can stream that, flow that. And finally, there is webhook, which is great for long-running operations. So the client says, okay, I've got this long task, call me when you're done, right? So you send the push information, push configuration. The server says, I acknowledge that. Here is the secret we'll share when I send you back the push notification. The server does its work, maybe for hours, maybe for days. Then it sends back, it calls, the webhook to notify the client We push information to the client. The client's got enough information to then do task.get to fetch some information about the task, maybe the artifact ID, the artifact results, and so on and so on. Okay? So, oh yeah, so by the way, it's pluggable, so you can, the spec is extensible, and there is a way to add more protocols, but these are the 3 standards. I know in our teams we're exploring with Kafka just to see what it would mean to have long storage messaging being passed along, right? What value it would bring. But from a handshake point of view, it's very static. So the server via the agent card describes the list of protocols it supports, and then the client knows which protocol it supports and choose one and say, okay, I'm going to talk to you in JSON RPC way. Right. So why do you have 3? I find that it goes against the notion of a protocol and a universal way to talk to one another. So I think it might dilute like the operability across vendors and everything, unless you support every single protocol on the planet that would be supported. We'll see where that goes. I would have stick with a single one, but I can see where in some environment you are only talking via JSON RPC or something like that. Okay. Next is, well, that's what I described. You can do sync calls. You can do streaming calls where you send part of the results, right? And then you can do push where you're literally disconnected from a client server point of view. And then you send back a push notification, and then the client goes back and say, give me that very specific task. You can, by the way, get the list of ongoing tasks. So you can get a state management and state operation here. And those are optional, streaming and push, and they are defined in the agent card to know whether your server supports it or not. From a security point of view, what the good thing about the spec, unlike MCP, is that they are talking about security. And they are defining what it's supposed to do, right? So it's not an afterthought of the spec. It's really bundled within, and you see the description in the agent card about the various protocols, and they've reused the open API approach, which is nice. So that's very good. You can get OAuth 2.0, which is where it's essentially where you have a valid ticket, a valid key which has less rights, right? You just give the rights that are necessary for the user. You can even pass the identity with OpenID Connect. You can have API keys, which is like, hey, here is the key to my home. Just don't abuse the system. You can have bearer token, which is more like a ticket, like a concert ticket. So I gave you the concert ticket. You can go to that concert. And then you got MTLS, which really identifies who is calling and who is being called in a safe way. Authorization is less defined, though it's expected to be in the same vein of open API. So you could imagine a granular control like with OAuth 2.0 scopes, for example, as a way to say, here is what you're allowed to do, or maybe propagating the GWT token and identity, things like that. Cool. All right, let's move to the demo. The demo has 3 main parts, but so you got a browser with a UI, right? And we're going to build a to-do application, but we're lazy. So if the to-do can be done by an AI, how about it, right? So we're going to try and do that. And to do that, of course, we have several agents that will be able to do some stuff for us, like give us the weather, answer information about movies, and you can imagine, additional ones. And those agents happen to use services in the backend. So there will not be MCP tools, but they could very well have been. I just didn't want to overlap too much. And there will be just simple function calls. Okay, so let's go on. Oh no, let's not do that. All right, so this is the to-do, but let me first start it. So you've got, it's using Quarkus. So Quarkus has a nice ability. So when I was working on that demo, like I started Quarkus with Quarkus dev or MVN Quarkus, dev. And then I didn't restart, right? I was just coding, adding classes, testing more, and then everything was reloaded. And here we don't see it anymore, but it's also starting a dev services with the Postgres database in the backend. So there's lots of interesting things. What I can do is open the the website, and then I would say, let's say, I had two tasks, like find what the weather is in Houston, hopefully not rainy this time, and then who played Sam in this Australian movie? And here I'm being vague because I'm hoping the LLM will play along here. Okay, so I've got the task. And by the way, while I'm developing things, I could also have what is called the dev UI in Quarkus. You got a set of, so each of those are dependencies like LangChain, which I'm using, Qt, which is the template engine, and then they have services to help me work on things. So there is the Hibernate one to see my entities and things like that. I can look at my configuration and change stuff. I can even look at my code and see what's going on. I do expose the various endpoints that I have. I can do something cool, which is continuous testing. So I'm starting the app, I'm doing continuous testing. So here we'll run the various tests. Hopefully they will be green. And once it's done, if I go back to the code and I edit things, and if I edit a class that would have been called by a given test, then that one specific test will be reloaded. So it's iterative test run, instantly. And dev services, as I was saying, is services that your app depends on. Of course, in production, it will be done differently, but in dev, it's just using a Podman or Docker to run those services. You got metrics, and you got other pieces. I won't go into more details. Okay, so I've got my to-do, but let's first look at the other agents. So the first one is the weather agent. The weather agent is, actually, let me show it in action first. So there is MCP inspector, and guess what? There is A2A inspector. So A2A inspector, you pass the URL, you click connect, you see the, let me make it bigger for you. You see the agent card, so you see that we use JSON RPC. There is not much capabilities except streaming and default input mode, output mode, what we have described. And the key thing is the description name are important because I'll use that to know whether I'm calling the right agent or not. So I could say, what's the weather in San Francisco? So if I click on it, I see that it's the JSON RPC model with message stream, which I support. And I've sent the message. So you see the message, which has parts of kind text. OK? No, it's not what I wanted. OK. And you see an artifact update. So here is an update on the result. And when I click on it, an artifact has an ID and has parts, which is like the results here. And you see the context ID that I was mentioning and the task ID because it created a task. OK, so that's the weather. How is it implemented? It's very simple. First of all, we delegate the hard part to a website, which is weather.gov, which has a client here where we just map the various get endpoint to call weather.gov. And on the front side, I'm just saying this is a tool, as in a function called tool, right? That's part of LangChain4j, that I will be able to use in my agent, which leads me to the agent. So Toolbox says, please be in a position to use the weather. By the way, Toolbox is super important. Mate showed it as well. You don't want to expose every single tool to your application. It will confuse things. It will open massive security holes. So select exactly for that interaction what you want. So this is, you could call it an agent, but here it's known as an AI service. And AI service has essentially prompt, like the system prompt here, which is, hey, give me the weather. And by the way, I'm not in the US, so please convert everything into a metric system, which is a nice usage for an agent. And then I'm passing the user message, which is what's the weather in San Francisco. And then hopefully it will do the right call to the weather and then come back with things. OK, but that's just an agent. It's a local agent. How do I A2A-ify it? First of all, I need a card. So here is the card. So I could have used the JSON file straight, but here I'm using a builder to actually build. This is exactly what was in the card that we saw in A2A. And then the next part is I need an executor which will receive message from the server, the sub-agent, and then do something about it. So here, the executor is receiving, let me zoom. Okay, where is it? Yeah, it got a request context, which is the request from the client, and then it's got the queue of tasks, going on and things like that. So I'm receiving that request. I'm trying to see if I already have a task in it, thanks to the task updater. And if the context says the task is null, it means there was no task created for that interaction. So I'm submitting a new task, and I send that information to the client. Then I'm start working on it, so I'm sending the working state to the client. Then, of course, I'm going to extract the message from the message coming from the client. I'll just pass that to my weather agent. Hopefully, it will reply something meaningful, and then I'll rewrap it into a list of parts, and then send that back and call it a completed task. Okay? So it's not too difficult to write a client-side, a server-side agent, right? Because you're actually deciding of the complexity, you're deciding you're doing a task, you're deciding when it's completed, and so on. Yeah, the rest is not. Oh yeah, well, I can get canceled the task. So if the task has already been canceled or is in a final state, it's an exception, but otherwise, it's all working. I imagine frameworks like ACP, like Quarkus or LangChain will elevate this experience, because here it's very low level and really at the A2A protocol level. I hope this will be elevated in the next few weeks or months. Okay, so that's the weather agent. And I have a second agent, which is a movie agent, which is written in JavaScript. And I won't pretend I can teach you JavaScript, so I'll just use it here using A2A inspector. You see here that they have history supported. That's a bit different than what I had before. Different, of course, description. The protocol is the same, etc., etc. Here they have lots of interesting examples, so that's super useful for the few-shot prompting. So I could read that agent card and pass that into some of my prompt to do the few-shot prompting on the client side. Okay, and if I say who played Harry in the first Harry Potter movie. So here I've got my request, which is a streaming request, and I'm sending some information. You can see the message being sent. Then I've got a task that has been created, so you see the submitted state. And you see the history. History is this is a message that led me to create that task. Then you're processing the request. You got a task ID, so that's your unique identifier passed along. And there should be a working state here, and the history is still there. And there is a final state with the answer, which, again, the same task ID. You've got the state which is completed. Now, funny enough, they are not using an artifact endpoint as a result here. So they, in the status, in the message under the status, which is usually something about the status itself, they are actually giving the answer. So you see different behaviors between servers in how they implement things. I think it would be nice to get an SDK, a TCK of sort to really standardize stuff and get tests. But we're not there just yet. No, actually, they do have a TCK, but more at the very low level. But here it's a bit too much flexibility from a server point of view. So the client has to be very flexible. No, again, not what I wanted to do. Boom. Okay. So let's see how it works on the client side. So if I want to visit Quarkus, I'll try to find whether there is an agent. And unfortunately, I've got the weather agent and the movie agent. So that's not enough, right, to actually work a website. So I have to do this one manually. Yeah, that sucks. So let's try and do the weather one. I'm asking to do it in AI, and I'm using WebSocket to connect to the server. The server says, hey, I think I've got an agent for you. That's the weather agent. Let me ask it. You ask with a status update. You see the task being submitted. You then see the task being working. So you see the same identifier here. Then you see a artifact update. So here is the result. Here's an update on the results. And you see my actual result in proper metric system, which is cool. And then you've got a status update to the final state of the task. And again, I've got the result again, right? So as a client, you need to be flexible into what you receive, what you display to the user to try and play with the various agents and how they behave. We were talking about it, the three of us, yesterday, and we feel that the artifact update could be very useful for chunks where you display stuff one at a time, and then the final complete answer might not need to be displayed in that case. OK, the other one is interesting as well. So I'm asking a question about a movie. Hopefully, it will find the movie agent. Yes, it created a task. This time, it's a task event, yeah, which is submitted. Then there is a status update working. Then input required. So I didn't give him enough information. Which Australian movie are you talking about? It's Penguin Bloom. Who's seen this movie? OK, I haven't seen it either. So I just played with like, OK, what weird question could I ask that would require a question? So here it comes back and say,
yeah, there was a typo in Penguin Bloom, so it wasn't sure it was the same movie, I guess.
OK, so you see several back and forth with the input, and boom, it's got information, and it cannot tell me what I was asking anyway. But that's life. That's the agent. That's a problem on the server side.
But it's a great movie.
Supposedly, with a penguin, so you know what can go wrong. So let's see how it's coded. Sorry, where's my code? Nope. There you go. OK, so I've got, I'm lost. What's going on? I've got the WebSocket, which is my entry point. I'm using the agent mediator is the one that will decide which sub-agent I need to run. Then I'm using the vertex event bus to talk to one another because I want to be asynchronous and disconnected from the WebSocket coming in and not blocking on the WebSocket. So I can do work with my agent and send message back up and back down the agent. OK? But I need a context for that because I'm starting with a to-do ID. And then at some point, there is a notion of a task ID or context ID. So how do I keep those unified? Well, that's a very interesting question when you write clients, which I ask myself. So here I'm creating an actual context object that tries to reconcile those things. Anyway, when the socket is open, when I click Do with AI, that's when the WebSocket is being opened. I'm essentially creating an event bus so I can interact with it. I'm passing the state, and then forget about agent ready. It's just like in case one agent is down, I just gracefully degrade. And I'm asking the agent mediator to initiate the conversation. Then when I receive a message, so it's a user that is sending me information like Penguin Bloom, and sending that information, I want to send that information back to the sub-agent. So if it's a user message, I'll pass the user message along via my mediator, which we'll see the code a bit later. And potentially, I can cancel the task. I don't know if you've seen it. There is a cancel button here. It's already canceled, and I'm not sure I coded it right, so I won't click it, but you got the idea. OK, so the next one is the agent mediator, which is really the core value that you as a developer will provide. OK, so I'm receiving the event bus because I will interact with it. And that's the message I've sent to do the async. But really what it does is calling the initiate sub-agent conversation. Let me zoom. So first of all, I need to find the right agent. So I'm building descriptor, which happens to fetch all of the cards from the producer. We'll see that in a minute. So all of the agent cards will be the information I will feed my agent selector to do something. And then I call the agent selector. And it's a relatively long prompt, but it says, hey, as an agent, you must decide which sub-agent could help me. If you're uncertain, please say that no, right? Don't try to use an agent for something it's not useful for. And my list of agents is dynamic from a prompt point of view. So I'm using the templating model in Quarkus here to loop across the list of agents, showing the name and the description. if it's not null. Then I do a few short prompting, and then I display what I'm actually asking, which is give me the weather in San Francisco, or find this movie about Sam, and so on. And here the parameters are the ones that are injected in the template: the list of agent descriptors, the to-do description, and the title. I'm running. Forget about the verify presence; it's not super useful. Then I can actually send the message, and I can use a A2A client, which is the interface to send a message. So here I'm building a message as a user and sending all of that information into. What else do I want to show you? Well, the next is actually to show you the producers. The producers is where I really initialize my agents, or the connections with my agents. So first I need to fetch the card. And the way to fetch the card is with the A2A SDK, card resolver, .getAgent, and then I stuck that in a map. The other interesting thing is to get the A2A client to interact. And how is the A2A client implemented? That's the interesting part. So you have a set of consumers. You've got your error handler management, and you got several configurations. And then you set up the client, right, with the transport. Okay. Now, the complex part is the consumer. So I'm receiving a message from the server. What do I do with it? Well, you got different types of message. It could be a simple message, not a task interaction, a simple message. So what do you, then I'm passing that information back to my mediator. It could be a task update event. And then in a task update, they are like the task itself and an update event. So I go into the update event types. Could be a status update or an artifact ID update. I look at it, and based on that, I will call my business methods that are sending the artifact back to the user, or sending the input required message to the user, or just sending the activity log, the stuff that were in gray, right? And you can see how it can be quite complex, because there are like very different cases that you need to handle that. Again, I think the frameworks will handle that for you and give you a higher level experience, maybe with annotations or something like that, that will be implemented at the mediator level. And the mediator level then receive those objects and do something about it. So when he needs to pass user message, of course, he uses the client and send that to the remote agent. You can cancel the task, which is also a message you send to the remote agent. And then when you receive message from the agent, you need to send that back via the WebSocket. So I'm using the event bus here to make that happen after extracting the information. For the artifact, it's a bit more complicated. The artifact is sometimes hidden. There are like several areas where it could live. So here, I'm getting the list of artifacts from the task update. Then I'm appending that. I'm sending that information. If I receive a task versus a task update event, then I need to either get that information there or finding it in the status. Remember, it was a bit weird that the movie was sending me the result in the status. Well, that's the workaround I'm using here. So you can see how the client is actually quite more complicated than the server. It has to be very reactive as far as any kind of interactions going on. Activity log, I won't go into too much detail, but again, that's the way. I'm also handling my context holder when I'm reaching the end of a task. Completed, cancelled, failed, rejected, unknown, then I need to remove the link with the task ID because I cannot reuse it again. Okay, so that's essentially what I'm doing here. Cool. Let's go back to the presentation if I can find it. There you go. So when should I use MCP and when should I use A2A? I think technically you could shoehorn one to look like the other, right? But so let's look at the intent and what they are really made for. MCPs are intended to be used by the local agents as tools, and they use the function calling approach to, to find the right tool to be called, and then the agentic framework you're using will do the right sort of interactions. And of course, MCP tools tend to expose So yes, as Mete was saying, there is a lot of ecosystem with a ton of MCP clients out there. Be careful what you accept within your organization, especially when there are upgrades, like somebody could sneak in and add some more adversarial versions, let's say. But where I see a lot of value is when you want to expose what's inside your application. So you might write a tiny bit of very specific MCP for your one API and really expose that. And that gives you very specific value for your organization. On the other hand, when two agents have to talk to one another, then the A2A protocol is much more useful, and it's flexible in its interaction that way. So if you have an agent-to-tool approach, go for MCP. But it's really contract-based. It's a well-known method, well-known parameters in, well-known parameters out. It has to be somewhat deterministic because of the retry capabilities of the MCP protocol. And if there is one thing that an LLM cannot be said of, is determinism. Right? So be careful about that. And you could see historically that MCP has been done for desktop-style tools, even though I think they have a great future for server-side calling, other servers down the line, but you could see the history here. A2A, it's when you really need a negotiation from a human point of view. Hey, I want to do that. Okay, you want to do that, but I need this information more. Or are you sure you want to do that more, right? So there's really back and forth, and the goal might actually change as you go along. Then the agent-to-agent protocol is useful for that because there is a way to do that sort of interactions. And it's very isolated memory-wise. You have this notion of task ID to really isolate various contexts. So it's very well done for this, parallel work around agents and things like that. Yeah, I think that's what I wanted to say. So should you go and use A2A? All right, so that's the reality check we're going to start. So first of all, I do upload the work that they have done, like having done work in specifications myself, I know how hard it can be. The spec is very well written, fairly clear. Yes, there are gaps. It's a 0.3, right? They expect people to give feedback. And if you want to build an ecosystem of agents, then this protocol is quite interesting, right? And the extensibility is, it can be tricky because it reduces the ability to interact with things because everybody needs to support the extensions. But on the other hand, it gives a life to the protocol. But it's very fresh. Not everything is super clean in the spec. There is like a couple of gaps and everything. I think the simple flows are well understood. I think the more complex flows are less defined, less clear for everybody, really. So we need to play with things and try to really see how complex the client, for example, has to be, considering the server can do many different things. I hope that will converge and stabilize here. So, yeah, it's always a bit surprising. So that's why tools like A2A Inspector or MCP Inspector are useful, because you might end up with something very weird and confusing from a state point of view. All right, then I'll swap Guillaume.
Matteo wanted maybe to show also the ADK and A2A integration, but very, very quickly, since
Sure.
we should be
My laptop, your laptop?
your laptop
again.
Yeah.
Okay. So close your eyes again.
That's a glitch in the grid.
Ooh, don't kill everything. Okay, I'm good. I'll hold the mic for you if you want. Are you coding or just talking?
No, I'll just talk like this.
Okay.
Yeah, I mean, since we have a little bit of time, I thought I would show you how ADK, Agent Development Kit, makes all the A2A stuff easier so that you have an idea. And as I mentioned, ADK is in Python, but there's also a Java version as well. So all of the stuff that I'm talking about will be supported in Java at some point. So how does ADK help with A2A? Well, first of all, as we explained, like there's the agent card that you have to create. And the way you create it is, whether in Java or Python, is that you create an agent skill that defines your functions, basically. And then from there, you create an agent card that has the skills and also has the capabilities like streaming and so on and so forth. So you had to define this yourself and keep it up to date. But in ADK, there you can install the ADK A2A library, and with that, there's this function called A2A. So what this does is that it takes your agent, and then it makes it A2A compatible. Okay. And what this means is that you get automatic agent card generation. So it looks at your functions and it kind of creates the agent card and agent skills automatically for you, which makes it easier so that you don't have to do it yourself. And if you change your agent or if you add a new function, then your card will be updated automatically, which is nice. So that's one thing. The second thing, and this is true for both Java and Python, I guess, is that when you have an agent, you typically wrap that into an agent executor. So this is kind of like the glue between your agent and A2A. And then, of course, that has to be served from a web server so that there's this A2A startup application that you need to wrap that agent executor into. And then you need to implement the agent executor. So there's this methods execute method. So this is a method that gets called when an A2A message comes in. So you need to take that and handle that. And then there's a cancellation method as well that if someone wants to cancel, you need to handle that as well. So typically you have to do this and you have to implement this yourself. But again, if you use ADK, when you do this A2A call and wrap your agent into it, this agent executor stuff is already implemented for you so that you don't have to do it yourself. Again, it simplifies things so you don't have to write code. So that's the second thing. And the last thing I want to show is that as you showed, like the actual client is kind of more complicated than the server in some ways. So for example, in Python, to do an A2A client, you create a resolver. From the resolver, you get the agent card. And then from there, you create a client with the agent card. And then you create your message and the request. And then from there, you send your request either in a non-streaming kind of way or in a streaming kind of way. So that's the way it works. But if you're using ADK, all you need to do is if you have a remote agent, you just create this thing called remote A2A agent and then point to its agent card. And with that, all that stuff that I mentioned happens automatically. So you can basically refer to your agent as if it's a local agent. So that's also another simplification of ADK. And just to show you a quick example, for example, if you have this kind of scenario where let's say you have a travel helper agent. It can have a local agent, like an agent like running locally, like weather agent. It can also have a remote agent, like say a currency agent that talks to a currency agent running remotely over A2A. So to do something like this, it's actually quite simple. So if we look at the currency agent first, and I'll just show you the code quickly. The only thing that's different than a normal agent is that you create your agent and then you expose it over A2A using this A2A call. So here I'm exposing it locally, but of course if it's running over Cloud Run, you can do that as well. So this is exposing your agent as a remote agent over A2A. And then in Travel Agent, so if you go Travel Helper, if you look at that, you will see that we will refer to currency agent as a remote agent and just point to its agent card. And then in the tools of the agent, we have the weather agent, which is an agent that's defined locally. And then this currency agent, it's an agent that's going to talk to a remote agent. But for this root agent, they kind of look the same. So for that, it doesn't matter. It will talk to both as if they're kind of local. So I have this sample, and you can run it if you like. But I just want to show you that ADK is trying to really make this easy. So all the details that we show you about A2A, ideally they're going to be like an implementation detail of the framework that you're using, and then we don't have to worry about it so much. I guess that's the point that I wanted to make.
Thanks for showing that. And so there's something in LangChain4j, especially for the call to the remote, that does that. But the implementation is very simple. It expects like text in and just text out, right? So I don't know about the complex use case, especially when you have an input required things. So I don't know if it's supported in there.
So I should mention, this just supports the simple request response for now. But I'm guessing going forward they will support more complicated.
I'm really excited to see how we'll be able to keep that that stuff simple the way you're describing it, which is what's in LangChain4j, but scaling complexity when we have those sort of interaction. I think that's the next frontier for the next few months for all of us.
Yes,
I guess so. Yeah, keep a watch on what's going on. I think there'll be a lot of improvement at that level.
Cool. That's all I wanted to say.
Yeah. So I wanted to show a demo which adds, which shows both MCP and A2A and back in Java. So let me just plug that back. All right. Let's see if it's coming. Yeah. All right. So I wanted to conclude this presentation with another demo, and that brings MCP plus A2A together. So we saw MCP, we saw A2A. Now let's try to put everything together. And my goal was to create some kind of product creative / marketing kind of assistant, or agent, you can ask for a new product, ideation phase, a new product, and for a particular demographics or target audience. So that's the idea. And although
I don't know what you're talking about.
And the thing is, what I like about A2A is this openness with regards to multimodality. So we didn't really show examples of, but you mentioned when you talked about the agent card, etc., that it supports not just text but other modalities. So, well, I'm not using the images with the A2A agent, but that's definitely the kind of things we could be doing, because we could interact with an agent, and maybe I'll refactor that demo at some point to do that, to talk to an agent that is more multimodal and generates images of new products, etc. Well, but anyway, so the idea is to create a multi-agent system. At least those agents are running together in one system. I'll be using ADK for Java for this example. So we have to give in input a product idea. We have to give the target demographics. Then the product strategist agent is going to give or generate a product brief, which consists of a product name as well as a product description. Then we'll have we'll store that in a database, and we'll see how I do that. Then we'll pass the product brief to the media creative, who's going to create the images of the product. Well, first it's going to create the image prompt for the image generation service. We create the images, and then we also pass the product brief to the marketing specialist, so that the marketing specialist is able to create some compelling social media posts about the new product that we've just created. Okay, so let's see more concretely in terms of to post in the social network. Let's see more concretely what it looks like in terms of the let's say architecture, how I implemented that. Maybe it's a bit far-fetched for an example, but I really wanted to show both MCP and A2A. So again, those three agents, sub-agents that work in one host application. The first, the product strategist is going to call an MCP client. And the idea I had was, yeah, maybe this MCP server would be the one responsible for like keeping track of all the products or ideas of products that are created, and it will save that information to a database. Maybe you could have argued that it could have been done in the same like system and reaching the right database, but bear with me, let's say, for this use case, because I'm trying to save something in the database, let's say some remote place. And on the marketing specialist side, that's where I have an A2A client that's going to call an A2A server, and this A2A server is the one who's responsible for the social network posts. And again, I'm gonna highlight this. Maybe I shouldn't shoot myself in the feet, but maybe we could have done or implemented that differently. And it's not really a smart agent here because I'm just faking something, but it's actually the marketing specialist who is preparing the social media post. But maybe we could have dedicated that to the A2A agent. But I mean, like in every use case, there are different ways to implement a use case. So let me show you this demo in terms of code. So I have, maybe I can increase the font size a little bit. Or maybe I'll show the demo running first. Oh, maybe I need to, can I decrease? Yeah, oops. So I have two servers running. So I have the MCP server that saves the product briefs into some kind of database. And I have another server here. It's the A2A server that's going to post to social media networks. And here, this is so let me rerun that, my product campaign. And then I'll show you the code, how it works. So, I'm not using the ADK dev UI because it doesn't show the pictures. So I vibe coded a little rendering of images. You'll see it's quite fun. So I need to create a product, and I need to target a certain audience to buy my product. So what about let's create an energy drink for DevOps attendees, maybe, like in my picture. And I am going to mention there are Java developers, mostly.
Or not.
I could say mostly, you know. I don't know if it's going to impact how the LLM is going to generate a new idea. So as I said, in there are different stages in that multi-agent system. So you saw the product strategist, media creative, marketing specialist. So they are going to work one after the other, actually. So let's see, the product brief. So the product is going to be called Lambda Lift. Okay, why not? And the brief mentions that it's for conferences like DevOps, and sometimes it adds like DevOps logo and that kind of stuff. So what's in yellow is actually which sub-agent speaks and what goes through. What is usually in black is what is written, well, apart from the logging messages. What is black is what is returned to the consumer, to the user, let's say. And then it's going to delegate or send the product brief to the product strategist, who's going to we are still at the product strategist level, sorry. So first it generates the product brief, then the product strategist does some function calling. So it will call the MCP server that saves the information in the database. So that's the product brief that is sent. And then it's also going to the product was saved here, and then you see, so the output before, so it's pixelated, but I'll show you the real picture since it's running in a terminal. And then I have the product strategist also called the media creative, and the media creative is actually an agent as tool. That's I have a talk on ADK where I'll dive deeper into the concept of ADK, but it's also a way to compose agents together. So an agent can also become a tool for another agent. And this is the prompt that it came up with. And then the product strategist is going to then delegate to the, where's the yellow? The marketing product strategist, who's going to interact. So we see the event being printed after, but the interaction came before. So you see some stuff logged before the finalization of the actual call. And you can see that I asked for actually 3 or 4, maybe 3 social posts. So it creates those social posts here, and that's what's going to be sent to the social networks. So let me show you just the real picture that was generated.
It felt like XCOM Enemy Unknown.
Yeah. So what is it like? It looks like more like an office setting, though. It doesn't really look like a conference. But maybe I could, I can ask follow-up suggestion. Yeah, but let's say it's a conference with vibes from the 70s to see if it's going to generate some fun.
Developers from the 70s.
I'm curious what it's going to do. And maybe while it's doing that, I can start explaining the code a little bit. So it all starts with this product campaign, which is composed of 2 agents. So it's actually a sequence. So the sequence is going to be first the product strategist, then the marketing specialist. So let's have a look at the product strategist. This is where I'm configuring so here I'm running the server locally. It's an HTTP server-sent event MCP server, but I could have deployed it on Cloud Run or elsewhere, but here it's running locally. So I say, okay, here's the address. I want to get access to the tools of that MCP server. And then I've got a long prompt that explains, yeah, given a product category, target demographics, you should create a product brief, which consists of a product name and a product description. And then I give some indications of what it should be doing. So you'll have to call the agent, so the name of the agent in the implementation is store product brief in database. So that is also something that LLMs understand. If you give it a meaningful name, it also helps. It helps to create a good description, but having good names for the tools also help LLM. And the last one will be to call the media creative to create an image prompt and the actual picture of the product. And there's also this notion of output key. That's where we will actually store the state of those multiple agents. So for those who attended the presentation, the LangChain4j agentic deep dive this morning, it's like the output name in the agentic scope. Here, it's a notion of state. It's pretty similar. And you've got output keys to say, OK, this is a big shared map. And here's the key under which we'll store the product brief. And I define the tools that are needed. So the database tool, which is the MCP one, this tool is actually just an agent as a tool. And we'll have a look at the media creative agent. And this one, maybe you've heard about the nano banana model. So it was quite popular, or it is still quite popular on a social network, because it's a Gemini model that is really great first at generating images, but especially at editing images. So it can, so maybe, let's see if the image, how it changed the image. It completely changed everything. But sometimes, so for example, I could, and it changed even the name actually, so it changed everything. Well, but depending on the prompt I use, sometimes I just say, I don't know, or change just the name, or change, I don't know, the color of the lava lamps, and it would be able to do that. But here it changed everything. So here I say, yeah, generate a high quality photo, aspect ratio with the description, and I can pass the details of the product brief with that notation. So that's a bit similar to what you can do with LangChain4j. And the trick here is actually I can retrieve the part, the multi-modal part that is generated. This is actually an image that is generated. So I look at all the parts and all the content pieces from the LLM responses, and then I can do whatever I want. So here I'm saving the file locally, and I also have this, and that's what I vibe coded, which is this little trick to actually print an image as on the terminal using like the, well, I don't need to explain those details, but it was quite fun. And I used the half blocks character in the ASCII table to be able to have the foreground and the background colors using ANSI escape codes, but it was fun. And that's how you can see the images where they're like showing up as very pixelated. So sorry, I don't need to tell you about those details, but it's fun. And where is so I need to go back to the product strategist. No, where is it? No, the product campaign, and that's where I'll have the marketing specialist that's going to call here. So the thing as well, so I'm glad that Mete got the chance to talk about the A2A integration in ADK for Python, because currently the A2A is a work in progress in ADK for Java. So the trick I did, because it's not yet ready for prime time, we're just getting started in the Java version of ADK, is that I created a tool, a function tool in ADK, which is actually just a kind of a wrapper around the A2A Java SDK. So this is what I'm doing, and it's the same kind of code that you saw in Emmanuel's examples. So I have this tool. So I'm describing the tool that's at the disposal of my agent, but within the implementation, I have the same code as Emmanuel for resolving the agent card, for preparing like all the consumers for my A2A agents, the error handlers, and then I build the actual client, passing the agent card, the consumers, the streaming error handlers, and I just need one transport, I just care about JSON RPC. And then I can transform a message into an A2A user message and send that, get the response, etc.
The negative things about that is that it's not well integrated into your network stack. So when your framework does what is expected, like metrics, tracing, and all of that integrated, like retries and stuff like that. So you have to disconnect it. So I know in the Quarkus side, that's the next work we want to do to really integrate that with the framework stack to then have everything integrated. I suppose that's what the SDK folks are working on.
Exactly, because it's really using currently just the low-level verbs and so on of the actual SDK, and not really yet integrating all the life cycle aspects, error handling aspects, etc. in a natural way with the framework that you use. Yeah, correct. All right, I think that's what I wanted to show about the demo. The MCP server and the A2A server are not very interesting to show, because I faked saving in the database and actually posting to social networks because I didn't want to send too much junk on social networks. There's enough such.
Yeah, I was about to say that doesn't compute to me.
All right, so yeah, that was the idea of trying to put everything together, A2A, MCP, and frameworks together. So let's summarize. AI agents are all the rage right now. They are everywhere. Everybody speaks about that. And there are many sessions at Devox itself that speak about AI agents. And we see like a flurry of frameworks and protocols and so on. But that's like last year, that was everything about RAG. The year before, we discover LLM. But this year, that's AI agents. So you have to get used to it, because you'll hear lots of stuff about AI agents. Clearly, if there were just two protocols you should be interested in and pay attention to and spend time learning about, that's clearly MCP and A2A, because that's the two ones really gaining traction and being integrated in all the usual frameworks and tools and so on that you're using, and all the languages, not just Java and Python, etc. So it's coming pretty much everywhere. And I really want to highlight the fact that the evolving part is important, because we are really building on somewhat of a moving ground, building on sound castles somehow, because especially if you remember, there was this table from Mete showing which one supports what aspect of the MCP specification, for example. And clearly today, not all frameworks support all the features and versions of the specifications. So the specifications evolve, the protocols like the transports are evolving, and just for the funny thing that my little demo is a bit fake and so on, and it's just to show everything together. But even just building that demo was actually quite complicated because as I was building it, I noticed that, hey, there's this framework not supporting, or let's say, well, I won't give names because I don't want to point fingers at anyone, but this framework slightly interpreted the MCP specification in a certain way. Like a certain SDK did things differently. Another tool showed that it was okay. So it wasn't really clear what was the actual or how things should really work.
Yeah, for example, the initialization that Mete discussed, like the first handshake, it was optional, now it's mandatory, and quite a few implementation from long time ago, as in like 2 months, are just behind, right? So now you're like expecting that from the client, you try, it fails, but technically you support the spec, they don't, right? So things are moving and not necessarily nicely backward compatible.
Yeah, there's a certain level of interpretation as well, because what's written maybe can be interpreted different ways sometimes, when the spec maybe is not super clear on a particular point.
But that's still better than nothing and stuff ad hoc. So that's the message, though.
So yeah, what I mean by this slide is that you have to try things, you have to experiment, you have to check what actually works or doesn't. Also see if your favorite framework supports the features that you actually need from the specification or server, whether it's MCP or A2A. So it was actually a bit nerve-wracking somehow to be able to finish that simple demo on time.
I think the most up-to-date things ever on the planet today. And like, honestly, go to the code that you will see and go to the LangChain4j one. So that's the code that actually works right now. That is the most
right now. But that was also, there was a bit of a conference development, driven development aspect, because honestly, that was awesome. So there's Christian in the audience, for example. I noticed something in the MCP SDK for Java, and then they released a new version. I also mentioned, I was using Micronaut, so I pinged my friend Sergi, and he also made some changes. And on ADK for Java, we haven't had time to do a release, but we were using an old version of the MCP SDK for Java, and that was kind of crazy to get everything to work on time. So yeah, there's this war, maybe it's not a war, but or a competition between those protocols and standards. So choose wisely depending on your use cases, and be ready for potential incompatibilities or things that are not always supported.
It's funny because there's been in Python, I don't know, Mete, if you've seen that, there's this tendency to say, oh, well, I'm using this advanced framework, but it's too much. I want to go back to very specific, let's say, OpenAI call, and they go back down. But then when you see those protocols, there'll be a swing back real quick because that's too far. So I think your best strategy is to look at what's your favorite framework or the one that is comfortable enough for you. What they decided to support or not is probably giving you a good clue into what are the good protocol to follow.
So that's about it. We'd like to share those 3 important QR codes. That's all the sweat and energy we put into those samples. So all the samples that Mete showed, the samples, demos, etc., that Emmanuel built, and the ones I just showed you, as well as the ones I'm going to show during the ADK for Java presentation. So they are all there. So I invite you to, take a screenshot. A picture of those QR codes. And otherwise, end of line. That's another quote from the movie. Thanks for your attention. I'll put back the QR codes if you want to have a look at the code.
Thank you. And
we have 5 minutes.
Yeah, we have almost 5 minutes more than 5 minutes for questions. So, feel free to shoot things at us. We can repeat the question and get going.
Yeah, in the front.
Yeah, one question about MCP. You did not speak much about security, but is it evolving on that aspect?
MCP security, who wants to take it?
So yeah, I answered that with somebody. So unfortunately, I haven't seen a lot of moves on the spec side around that. The one thing I recommended for the person is the frameworks actually are exploring things. So I know, I'll just speak on the Quarkus side because that's the one I've seen, but I imagine you can see other stuff. Is if you look at Quarkus/blog, quarkus.ai/blog, you look for MCP, and the person handling security has been showing quite a few examples of how do you secure on the client side, how do you secure on the server side, using an OAuth2 server. So look at that. Look at how he uses scopes, for example, to secure things. But there are quite a few layers of security to think about with MCP. There is like, do I have the right to call that thing, and is it safe, right? But the other one would be, well, do I receive malignance, MCP via an upgrade? How do I protect from that? That's more of a supply chain security aspect that you need to deal with. The final one is probably, do you trust your LLM provider to not, reuse your information that might be sensitive for you? So that there are like quite a few different classes of security. I don't have a good...
Just in case there's... I don't want to point fingers at Christian, but he's here and he's implementing the MCP SDK for Java. So he knows the spec,
Have you seen much move around that, or in the secure side? Have you seen much move in the security?
Hooks to propagate.
Yeah.
Different frameworks.
Okay. Yeah. Okay. So the Java SDK has hooks because each stack actually implements it slightly differently, Spring or Quarkus or Micronaut, etc. So the hooks are there to propagate the right context, like your GW token or things like that. Maybe one more question while we have a couple of seconds more.
There in the staircase.
So preferred transport, definitely you can. So the server, yeah, that's a good question you're asking. So there are like two levels. The first one is the transport, where there is a preferred transport, but technically the client can use any of the transport described in the card. And I didn't show it because JSON and slides, they don't mix well together, but there is an additional interface, I think they describe that, where you could say, here is my gRPC way to support it, here is my JSON over REST way, or maybe here is the Kafka way to support things. So that would be the way to support additional transports.
Yeah, are we...
Okay.
Right?
So that's the way to support additional transports. The input mode, when you say by default, it's the default within the skills, and the skills can override what they accept in and what they accept out. So here, if you say that you support something what's interesting is like, I don't know if you've seen the weather, I think, or the movie, they supported like MP4 as an output. I was like, whoa, that's going to be interesting to support on the client side. Unfortunately, I haven't seen a way to say, please only send me text versus MP4. I don't know that it is not part of the spec today, but maybe that's an interesting one to say, as a client, I don't want images, for example. I don't support them or something like that. Okay, we're red and blinking, but we can stay around a few minutes if you guys are interested in more, non-public questions and conversations.
Thank you again.
Thank you very much.